We are going to get started here right now. So thank you everyone for being here. Day 2 of our 10th annual workshop. We got a great day of programming ahead of us. Also a few things to note for today. Scott Fenema, who runs the river, as Tom says, is going to give us a Lake Tahoe Dam tour starting at 3:30. So we'll wrap up here at 3. You can look at the location here. It's going to be great, and we'd love to see you all there. So I'm sure there's plenty of carpool opportunities, so grab a group, and we'll see you there. And then additionally, tonight we'll have our banquet. There is a little suspicious weather in the forecast, so whether or not we make it up to the mountain is up in the air, but we do have a great backup plan in the village. So come this afternoon, I will have a finalized plan for you all. And yeah, we'll have a great night regardless. So without further ado, I'm going to give it to Kate to run today.
Thanks, Molly, and thanks for all that you're doing running the workshop. Hope you all enjoyed yesterday, our California Operations Day. Thank you to all the speakers. It was a really great day, jam-packed with information. Today, we are going to shift a little bit eastward, our focus on Colorado and Utah operations. And to kick us off today, we have Erik Skeie, Special Projects Coordinator for the Colorado Water Conservation Board and the de facto leader of our Colorado Airborne Snow Measurement Program. And he is going to tell us a little bit about that work.
Thank you, Kate. Thanks everyone for having me here today. So this year was actually a momentous occasion in the Colorado program. So I found it appropriate to give you the full history of the Colorado Airborne Snow Measurement Program, as opposed to my usual short versions. So it all began back in 1937. The nation had just endured the Dust Bowl. Tom Painter had just turned 60. And the Colorado legislature passed a bill that formed my agency, the Colorado Water Conservation Board. We were formed as the state of Colorado's policy and planning agency. Now, we're the second water agency within Colorado, so it can get a little confusing. So I do have a shorthand to remember who we are, as opposed to our sister agency, Division of Water Resources. They hate it when I make this comparison, but it's true. Think of CWCB as the fun parent of Colorado Water. Well, DWR is going to be telling you when you can divert and where you can use your water. We're the ones who are like, hey, you want to measure some snow from an airplane? Here's a couple $100,000. Go have fun. So that's the key difference between our two agencies. Now, began in 1937. It took just over 70 years for us to start thinking about snowpack and snow data measurement from a state perspective. Before then, we had been relying on the SNOTEL stations, snow courses. But my predecessor, Joe Busto, had been hearing about some issues that were occurring in southern Colorado. You see, on top of all the complexities you've heard this week thus far of irrigators, municipalities, all these different water uses, on top of that, Colorado has to deliver water to our downstream states. And in the Rio Grande Basin, they were having some serious issues with the stream flow forecasting. There was not enough data on the snowpack to get an accurate forecast. And so when they had to administer their compact, it's a little different than the other ones that we have in the state, but they have to deliver a % of a flow above a certain amount. So if that forecast is off, they have to continue delivering that water to New Mexico until our obligation is fulfilled. So you can see how an inaccurate stream flow forecast could really throw a wrench in the works there. Now, predecessor Joe Busto, he had a similar thought to Dave Rosardo. There has to be a better way to do this. And we threw a smorgasbord of science at the Rio Grande Basin. Told you I was going to say that today. We had radars. Dave Gotches was out there throwing out weather stations, stream gauging stations. He was gauging the Conejos Basin like you wouldn't even believe. And on top of that, we had heard about this little program from NASA called Airborne Snow Observatories. They'd done their flight in 2013 in the Uncompahgre, and we're like, maybe that would help us out down here in the Conejos. So 2014, on the eve of Tom's 60th birthday, we started this big operation, the Rio Snow Flow Experiment, radars, ASO, stream gauges, oh my. And we found that this ASO data was exactly what we needed to get a better picture of the snowpack and refine our stream flow forecasts. And at that point, I came on board to the CWCB as an intern, and Joe Busto took me under his wing. The selling point for me on this information, we were ground truthing the data. We were at the Upper Rio Grande Snowtel Station, so imagine I'm the Snowtel Station. It was reading 0, no snow, no SWE, no nothing. To that wall there, snowpack, tons of snow, but they couldn't see it. And that really sold me on the idea that, oh, these point measurements, while they are still going to be the backbone of our snow data, they're not the end all be all. We need to do better and do better things. And that converted me to what I'm going to call a used data salesman. Because Joe Busto and I then spent the next 4 or 5 years traveling across the state to any meeting we could possibly get into and say, hey, have you heard about the thirst-quenching power of SWE data? And we were trying to get this information and this data across the state. As you can imagine, state government coming around saying, hey, we got a data product for you. That didn't go too well. We had very slow progress in building the program up on our own, trying to go it just by ourselves. Around the second year, we were able to expand into the East and Taylor River basins and the Gunnison. Then we were able to slowly move our way in the Southwest with the Dolores Basin, but we were just struggling in gaining that traction and getting our funding levels up to where they needed to be to really kick this thing off. Well, come 2019, the folks you're about to hear from today after me, they came up with this awesome idea. You see, in Colorado, we have this conference called Colorado Water Congress, similar to this, but all the water nerds of Colorado come together into one meeting and they talk about the issues of the day. This group of stakeholders, municipalities, conservancy districts, you name it, they were there. They came together and they thought, we need to make this information statewide. How do we do this? So they joined forces and they applied for a grant to come up with a feasibility study to see what would it take to make this airborne snow measurement a statewide program. And they saw that it was actually feasible. It would take a little bit of money and a lot of time and a lot of people on board too, but it was feasible. Then 2020 happened. Nothing really important happened in 2020. You know, it's all good, just 2 weeks, nothing there. But while we were shut down in the world, this group continued to work. And they came up with a plan. They had just released that feasibility study, said, hey, it's possible, but we need funding. So they banded together once again and worked diligently throughout the year to come up with a pilot project to expand this to more basins than we had ever flown before. And they got a $1.8 million grant from the state to really blow this program up and make it a lot larger deal. Now, I was both excited and nervous at the same time because this was the first time we had ever had this many flights in this many basins in the state, and I didn't know how to run it. Thankfully, California had already begun running their statewide program, and Dave Rizzardo was kind enough to let me pick his brain on how they run the program. He even let me sit in on some of his meetings, a fly on the wall, if you will. So we pulled that program structure straight from California's ARS, and we implemented it in Colorado. It's their acronym. Come on, guys. So we started implementing that program structure in Colorado. We had our management committee, which consists of a lot of the folks you're going to hear from today in Colorado. And then we had other different committees, flight coordination to make sure our stakeholders were getting the data when they need it, where they need it, all that good stuff. And it began ballooning from there. Now, when this first started, we weren't sure if CWCB staff was going to have the time to run the program. So Taylor Winchell, who you'll hear from later today, ran it for a long time. He was managing this program. This plucky group of volunteers was leading themselves to this amazing data program. But after a while, this group was like, hey, we really need state leadership. We need you guys to step up and take it. And we were able to get permission as CWCB staff to run this on sort of like a pilot trial basis. It still was not an official state program. So for a few years, CWCB has been leading this little ad hoc group, this group of plucky volunteers and stakeholders who took this thing and blew it up. Remember, 70 years before Busto came along, started doing this program. Another 5 years, we barely expanded it from 1 basin to 3. And now we've got 20 flights throughout Colorado. And I think we've got, what, 7 or 8 basins, but the Front Range is considered one, even though it's a whole bunch of different ones. But anyways, these stakeholders were the catalyst for us to get a program. And they kept pushing that the state needed to take leadership. And it was a really tough struggle as a state employee to try and make that case. But they, a couple years ago, wrote a paper about why CWCB needed to take this on, why this needs to be a state-run program. And that paper made it up into the upper echelons of DNR. And last fall, a bill was introduced to make a snow and water program an official program in the state of Colorado. That bill passed May 1st, 2025, which is amazing. So the first time in almost 90 years, the state of Colorado recognized the importance of snowpack data and made it its own program. And it would not have happened without the folks you'll hear from today, without my predecessor, Joe Busso, without these awesome people here. So it's really a story of getting your stakeholders excited about new data and why they should be excited. Why is this important to them? These folks were able to recognize that and really run with it and make this a statewide program. So a couple weeks ago, my parents were in town and my mom was asking me about work. She's like, hey, how's this snow thing going? I go, Mom, we got a program. So that is the full story of the Colorado Airborne Snow Measurement Program. I didn't want to talk about data because the folks behind me are going to be talking about the data and how they actually use it, but I get to work with the best people in the world. They're absolutely incredible, and they're the whole reason the state of Colorado was able to make that happen. So thank you. That's all I have for today.
How old does that make me now?
Well, let's see. This week is your 60th birthday again, so.
Are you still working with the state of California, sharing information and program advances?
Not in recent times, but with this bill also giving a full-time position towards this program, that's definitely going to be something that it will be pursued. Because, yeah, we'll actually have the time and capacity to do that.
We keep seeing changes with the program. We keep advancing with them and the interactions with not just Dave, but with the whole group.
All right. Well, thank you all.
Thanks, Erik, for that fun history lesson. Next up, we have Raquel Flinker, Director of Interstate and Regional Water Resources with the Colorado River Water Conservation District. Thanks for joining us, Raquel, and thanks for understanding we were a little ahead of schedule, but glad to have you here.
Thank you. Can you guys hear me? Yes. Yes. Okay. Let me share my slides. Thank you so much. Thank you for having me. I am, hopeful that I can join in person next year, but I'm glad that there's a virtual option. And as Kate introduced me, I'm Raquel Flinker. I'm with the Colorado River District, and I'll be talking about airborne snow measurements in the Gunnison Basin and the importance of it and how we have been using it. One sec, wait, here, this, you can see this now. And so before I dive into that, I just thought it would be helpful to talk a little bit about my organization, the Colorado River District, and what we do. So we were formed in 1937 to protect West Slope water users and to safeguard for Colorado all waters of the Colorado River to which the state is entitled. So we do have this two-part mission. The first one focused on protecting West Slope water and West Slope water users, and the second piece focused on larger Colorado River Basin issues. And here's a map of our district. Here's the state of Colorado, and in blue, the area we cover. So we're a local government. We cover 15 counties on Colorado's western slope. And I do want to point out that our eastern boundary, this jagged line here, is the Continental Divide. and it splits the population of the state of Colorado as well as water flows. And so most of the water is west of the divide, and most of the population is east of the divide. And where is the Gunnison River Basin, you may ask? So it's south of our district, here in this green circle. And the Gunnison River contributes a lot of the flows of the Colorado River at the Colorado-Utah border, around 40% of the flows. So it's a major tributary to the Colorado River. And here I just want to show you where 3 reservoirs are located that I'll be talking about. The first one is Taylor Park Reservoir, sits on the Taylor River, which is a tributary to the Gunnison River, and it has a capacity of around 100,000 acre-feet. Next, we have Paonia Reservoir, a smaller capacity, 20. This is the total capacity, not the active capacity. So it has around 20,000 acre-feet. It was built in the 60s. It sits on Muddy Creek, which is a tributary to the North Fork of the Gunnison, and then merges with the Gunnison near Delta. And the last one is the Aspinall Unit, which is composed really of 3 reservoirs, the largest one being Blue Mesa Reservoir. It's the largest reservoir in the state of Colorado, and they were built in the 70s. And Blue Mesa is really important for regional water management, but all of these reservoirs are important for water management in the Gunnison Basin and beyond. Taylor Park Reservoir is part of an larger irrigation system, and until a few decades ago, it was managed solely for irrigation uses here in the Montrose Delta area. And anyhow, that has changed, but why this basin is using ASO flights is, as a lot of other areas in Western United States, we're seeing increased demands and reduced supplies, and it becomes more important to better understand our snowpack. I do want to call out that, kind of as I was mentioning, so in the 70s, there was a Taylor Park exchange agreement that allowed water from Taylor Park Reservoir to be exchanged into Blue Mesa and vice versa. And that is what changed the way Taylor Park Reservoir, how it is being managed, because this water, the first fill, can be moved into Blue Mesa, and that can be managed for irrigation uses here. And then the actual physical water in Taylor Park can be managed for benefits to the Upper Gunnison, which is this whole area. So multiple benefits in this area. Anyhow, so a bit of why the ASO flights, or the impetus for some of this work, is that water managers in this area, but throughout, I'm sure, the Colorado River Basin, really rely on Colorado Basin River Forecast Center's forecast. And there are uncertainties, of course, as with every forecast. Some of the uncertainties are particularly significant in the Gunnison Basin, especially for Paonia Reservoir on the North Fork. There is a mean absolute error of 20%. And you can see that it varies quite a bit, right? So the mean error is 14,000 acre-feet, but it can be 80. For you to have an idea of the significance of this, is that the active capacity at Paonia Reservoir is around 15,000 acre-feet. So it is a relatively small reservoir to the size of the watershed, but this is equivalent to its volume. And every spring, the managers of these reservoirs have to decide when to shut the gate, when to start filling. And it is a pretty important decision, as if you close too early, you can increase amount of sedimentation in this reservoir. It is on Muddy Creek. It has a big sedimentation problem there. You know, if you close the gate too late, you could not fill. When we look at Taylor Park Reservoir, the mean absolute error is 11,000 acre feet, which translates to flows of 400 CFS for 2 weeks. And that is a really significant flow for the Taylor River and can totally change boating opportunities in the fall when flows are low. And you can also see that, you know, the range is significant as well. So depending on the year, that could even be higher. And then lastly, just, oh, these bullets over here. And then lastly, talking about Blue Mesa Reservoir, where the mean absolute error is around 70,000 acre feet, and you can see the variation here. And why this becomes even more critical for Blue Mesa Reservoir is that the determination of the year type for operations of Blue Mesa, they're determined based on May 1st forecast. There's some wiggle room to modify operations up until May 15th, but those forecasts determine peak flows and downstream of the reservoir. And depending on the year type, it completely changes the requirement for these peaks downstream. And so you could be releasing a lot more water if you fall in a certain year type versus another. And it becomes a very important decision and implicates the amount of storage left at Blue Mesa Reservoir. All right, so just a flag or a call out to the group that currently determines management of Taylor Park Reservoir, which is the Taylor Local Users Group, and it's composed of irrigators, recreation folks, boating, but fishing as well, local property owners, municipalities, and this group has to balance a lot of different needs. And the flights, the ASO flights in the last several years and the forecast associated with the ASO flights have been extra information that has been used to modify operations of Taylor Park, and they have you know, decided to reduce spring releases this year, last year as well, so that, because in previous years what was happening is that you had determined your spring releases, and then runoff wasn't as good as you had anticipated, and then in the fall you were kind of stuck with having to make really low releases to make sure the content objective of the end of the year was met. And anyhow, okay, so moving a little bit into talking about Blue Mesa Reservoir and our hopes for ASO flights and how that can inform decisions there in coordinated reservoir operations. So just to show here how water is flowing, right? So you have the Taylor and merging into the Gunnison. There are a bunch of other tributaries. Then you have the North Fork that flows here and merges with Gunnison near Delta. And here is the releases out of Blue Mesa. And all of this, right, goes downstream, and the Gunnison merges into the Colorado River near Grand Junction. But importantly here, between Delta and Grand Junction, this is critical habitat for endangered fish. And the record of decision for Blue Mesa Reservoir determines peak flows measured here at Whitewater, at a gauge here, but near Junction. And just to understand the complexity there. So, but in addition to operating this reservoir for purposes downstream here, it also is managed to meet flow targets at the Black Canyon of the Gunnison National Park, which is located right downstream, located here. So the way the record of decision works is that it says we're going to release these peak flows. The peak flow releases are going to be made in a coordinated effort with peak flows at the North Fork of the Gunnison. So when they know the North Fork is going to peak, that's when they start releasing water to meet these peak objectives here at Whitewater. And that is, you know, not necessarily the easiest thing to do, of course. And in 2023, what happened was they started to increase releases out of Blue Mesa to reach these targets. And the North Fork started to peak more significantly than anticipated. There were flooding concerns in Delta County. And so the Bureau had to ramp down the releases out of Blue Mesa. And later on, they had to ramp it back up to meet these peaks. They weren't able to meet the peaks, so they had to do it later in the season. And that, you know, caused some concerns from stakeholders in the area, mainly because it impacted the amount of water left in Blue Mesa, right? And the concern is, you know, how can we avoid this in future years and things like that? And so the ASO flights can inform those decisions as well. At least it's the hope. And why we made the case for ASO flights in the North Fork as well this year. So in 2025, for the first time, we had ASO flights in the North Fork of the Gunnison, and we continued with ASO flights in the East and the Taylor River. I should say, because I was supposed to mention this earlier, but the Upper Gunnison Water Conservancy District is really critical in all of these efforts and have been a big advocate for these flights. The East and the Taylor River flights have been going on for a number of years, I believe 8 years, and it's pretty important data set, you know, in a longer term data set, which is why this year, for the first time ever, CBRFC incorporated ASO information into their official forecast. And you can see this significant drop here in their forecasting. This vertical drop, it was when they incorporated the ASO data into their snow model. And so they removed snow above 11,000 feet and resulted in that significant drop. And the reason why they were able to do it this year is that they have seen these flights for the last 8-ish years and have seen the importance of them and how they can better inform their models, and felt confident to incorporate it. And so I think that's a real benefit of having multiple years of these, so that we can trust and know where and when to trust and how to use. So just to finalize here, the importance and why we conduct the snow measurements in the Gunnison is to optimize and help with future optimization of reservoir storage, to ensure we comply with endangered species requirements, and balance and meet multiple needs, right? Ag, stream health, recreation, and also maximize hydroelectric generation. The Aspinall unit is a really significant power producer, and you know, this can be important. And lastly, there's a lot of research and science that happens in the Upper Gunnison, and they have relied on ASO flights to better understand, management of forest, snow characteristics, runoff efficiency, and so on. So that is the end. If there are any questions, I'm happy to take them. Thank you.
Okay, thank you, Raquel.
Thank you.
Let's see, next up, we have Taylor Winchell and Marin MacDonald. Taylor is the climate adaptation specialist for Denver Water. Marin is an intern with Denver Water and also a master's student at Colorado State University. They are also presenting remotely, so we'll just get them queued up.
Awesome. Thanks, everyone. And hello, I'm Taylor Winchell. I lead our climate change adaptation program here at Denver Water, and I've been involved with the Colorado Airborne Snow Measurement Program, or the CASM program, since it was getting off the ground in 2021. So it's been a really great journey to be on with folks from all around the state who you're hearing today in the Colorado session. Marin and I will be co-presenting today, and I'm just going to give a brief overview of where Denver Water has been able to fly in its watersheds in the past, and a little overview of Denver Water. And then Marin will dive into some really neat analysis that she's been working on this summer as she's been interning at Denver Water and finishing up her master's at Colorado State. So Marin, you can go to the next slide. So just brief high-level overview. Denver Water, we're the over 100 years old now, and we serve potable water to about 1.5 million people in the state of Colorado, which is about 25% of the state's population. And we do that consumptively using less than 2% of the water used annually in the state of Colorado. We have a pretty large and complex collection system that is based off of surface water that primarily originates from the snowpack. And that comes from both sides of the Continental Divide. So about 50% of our water supply comes from the South Platte River Basin, about 50% from the Colorado River Basin. This covers, our collection system covers about 4,000 square miles of watershed area. And then, as you can imagine, it takes a lot of infrastructure to do this. So we have enough pipes to just about stretch across the United States. And so this is what our collection system looks like. As mentioned, it's pretty large and complex in a variety of ways. But that red outline kind of towards the right of that map there, that is our service area. So the city of Denver is in there, along with some surrounding metropolitan cities and towns that we serve water to. And then the rest of those highlighted watersheds are our collection system. In that dotted red line is the Continental Divide. So everything to the right or to the east of that dotted red line is the east slope or the Front Range of Colorado, which is the South Platte watershed. And then everything to the left is the Upper Colorado River. Those are watersheds that we have trans-mountain diversion tunnels that take water from those watersheds as part of our overall water supply. And you can go one slide forward, Marin. And so these areas are areas where we've been able to fly ASO flights in our watersheds going back to 2019, where we really started in the Upper Blue River in 2019 and have been able to fly there every year since 2019, except 2020 due to COVID budgeting reasons. And so, yeah, we've really been diving in and using this data in a variety of ways and seeing how it fits into our system operations. You can go one slide forward. So this is just one example that Nathan actually presented a bit to last year during this workshop. But this is the Upper Fraser River watershed, where we actually have about 30 diversion points, which are all those red triangles that you see. And those are manually turned on and off by operators that work in that system. So it's a really complex system that is dependent on snowmelt, and there's very large number of decisions made every year within this system to know exactly where we're pulling water from and how dynamically to pull that water. And I think historically, it's kind of more been the practice to sort of turn all the diversions on at once because we didn't have a really great image of, which sub-watersheds might have more or less water. And now we've been able to find that with ASO data, we can break down within these really small sub-watersheds above these diversion points how much water we might reliably expect to divert in individual diversion points, which then allows us to maybe not divert water in some of these areas and let that water have a higher impact on like maintaining environmental flows downstream in the Fraser River. And so what we've done historically is you can see that graphic on the right there is there's a forecast point here from the CBRFC, and we've tried to use that to forecast water stream flow in some of these sub-watersheds throughout the basin. And just because of the complexity of how these kind of watersheds are set up, some of the geospatial features of the watershed, we've had a really hard time doing that, just kind of like extending this one forecast point to the sub-watersheds in this basin. And if you go one slide forward, but now that we're able to break this down sub-watershed by sub-watershed here, we're able to really gain confidence in knowing that there is kind of enough snow, enough water above certain diversion points in order to meet our water supply needs from those sub-watersheds above those diversion points. So this has been really helpful for us in making seasonal operational decisions on where to divert water from. You can go one slide forward. And so as I mentioned, we've been flying in the Blue River watershed above Dillon Reservoir back through 2019. And I think one thing we'll get into a bit today, and that Marin will kind of come to at the end with her slides, is sort of what the heck went on in 2025, which I'd say is a mystery that we are still very much working to unravel. So what you're seeing here is data from 2019 through 2024. And what we have is our first ASO flight, which in that watershed each year, which we aim for to be around the peak SWE time. And then the April through July inflow as taken from the CBRFC natural inflows. And you see this really tight relationship between that kind of quasi-peak SWE flight and the April through July inflows. So, feeling great about this. And then if you go one slide forward, you can see how 2025 fits into this picture. So we really didn't see the snowpack materialize into stream flow this year, even though there was, it was our second highest recorded ASO value in that watershed. And so I think there's a lot still to come on breaking this down and understanding why that snowpack didn't materialize. And with that, I'll pass it over to Marin.
Thanks, Taylor. Can everyone hear me okay? All right.
Yeah, we can hear you.
Okay, cool. So as Taylor mentioned, my name's Marin. I'm currently the water resource analysis intern at Denver Water. I'm also a master's student at Colorado State University studying snow water resources. And as part of my internship this summer, I've been looking into some SWE characteristics, specifically in the Blue River Basin, using some of the ASO flight data that we've gathered. Specifically, I've been looking at the years 2021 through 2025. With the start of my analysis, I was first just focusing on 2025 to see how it's compared to previous years and previous flights. So doing a little bit of comparison between our quasi-peak SWE flight as well as our mid-melt flight to see how much loss we've had in acre feet between those two flights this year. You can see there's a 1-to-1 or 1 to -1 scale on that top left corner, and that outlines the Blue River Basin. You can see up in that kind of northwest corner of our basin, we had some big losses in the 10 Mile Creek area, which is interesting to see where we're having our biggest losses between that, again, peak SWE flight and mid-melt flight. And looking at just median volumetric SWE compared to the 2021 to 25 years, you can see we actually looked like we were doing pretty good at that peak flight and mid-melt flight in terms of expected SWE output. So to better understand spatially what's going on in our watershed, I then took some spatial features looking at elevation, slope, and aspect to see how over space that SWE is changing year to year. And the first way that I looked at that was by creating some fun heat maps. I know these are a little confusing at first, but over here on the y-axis, we have our elevation bands separated out by 100-meter zones, and then our aspect separated out into our 8 cardinal directions. You can see here, based on that, most of our SWE is being stored within the basin at that 3,100 to 3,700 meter range. Most of our SWE is also being stored in those like north through east facing aspects, which based on solar radiation being one of the main drivers of snowmelt here in Colorado, it makes sense that we're having a larger clustering of SWE or higher cumulative SWE values in those north through east facing areas. If we want to look at just elevation in terms of how it's impacting our cumulative SWE, we can see here, this is for all of our years that I'm looking at, so 2021 through 2025. We have our elevation now on the x-axis and our cumulative SWE in acre feet on the y-axis. And you can see here at that start of the season, start of the runoff season, that flight, we have pretty high cumulative SWE values, especially compared to some of our other years on record. You can see 2024 and 2025 are in the red and purple there, pretty comparable at that 3,400 and 3,500 elevation range. And then we can see that there's a pretty steep drop in the amount of cumulative SWE we still have in the basin between those two flights. So we don't just care how much cumulative SWE we have, but we also want to understand how much of that is actually getting into Dillon, since that is one of our trans-basin diversion systems that brings water into the South Platte. And to do that, I've been using the CBRFC seasonal observed flows going into Dillon, as well as PRISM simulated data. So that takes daily precipitation for the whole basin and averages out cumulatively to get precipitation totals for April through July. And then also using the April to July CBRFC forecast data as well to see how those are comparing to our cumulative SWE totals. And with that, we get a simplified version of a basin runoff efficiency calculation, just a snow to flow calculation. So looking at how much the CBRFC observed in our basin going into Dillon with how much cumulative SWE we had from that first flight at the start of the snow season and how much cumulative precip from PRISM we could expect as well. You can see here the years 2021 through 2024 are pretty similar in terms of efficiency for the basin. We have, mid to high 70% for that basin runoff efficiency. But then you can see here, 2025, we have a huge drop in efficiency going down, about 20%. Even though we had that higher cumulative SWE total, we did have a decrease in cumulative precipitation by quite a bit. And it seems that potentially that prolonged dry period impacted our efficiency pretty significantly. So the amount of water going into Dillon was far less than expected based on our ASO flights. So going forward with this project, I'm planning on dividing up the Blue River into its sub-basins, so looking at specifically 10 Mile Creek, Snake River, and Blue River to see how each sub-basin does on efficiency to try and figure out where we're getting the most out of our basin, and also expand this methodology to our other headwaters basins, such as the Fraser, as Taylor showed, and some of our South Platte stations as well, to see how throughout our collection system that efficiency is changing as well. So if anyone has any questions, I think we have time for those. And I'm also available offline if anyone wants to discuss further.
Any questions for Taylor and Marin? Oh, yes, up on the screen. My eyesight is not that good, but Ravindra, do you have a question?
Okay, Marion, first of all, very nice presentation. I do have one question. How are you defining cumulative SWE in your work? Thank you.
Cumulative SWE is calculated using the ASO rasters, and those, sorry, I guess I should have mentioned units. That would be an acre feet of water.
Okay.
Yeah, and we've generally for those flights in the Blue River watershed have tried to align the first flight of the season with approximately basin peak SWE. And so that's what we're kind of calling like the basin-wide peak SWE of the basin in each year.
Thank you, Taylor.
Great. Thank you so much, Taylor and Marin.
Thanks, Kate. Hi, everyone. Let me share my screen quickly. Yeah, thank you for having me. Yeah, I'm at Northern Water, and we've been using ASO data for a few years now, and so I'm happy to tell you a little bit about how we use ASO data at Northern and also what happened this year. So if you aren't familiar with Northern Water, we are also known as the Northern Colorado Water Conservancy District. We were started in 1937 to co-operate the Colorado Big Thompson project with the Bureau of Reclamation. The CBT project delivers water from the Colorado headwaters. I don't know if you can see my cursor, but from the west slope, from the other side of the Continental Divide over to the Front Range municipalities in northern Colorado. And that's through the Adams Tunnel, which is shown as a dotted line on the map. The service area is shaded green on this map. So the northern Front Range gets the deliveries, and then farther down the South Platte benefits from the return flows from that water that's delivered. The project delivers water to over 1 million residents and over 600,000 acres of irrigated farmland in northeastern Colorado. It's made up of 12 reservoirs and 6 hydroelectric power plants. So that's on the west slope and the east slope. So there are countless critical operational decisions that we need to make to run the system. So Lake Granby, our biggest reservoir, is it's our largest reservoir, so the inflows to this reservoir are generally the most important in our system, although Willow Creek also feeds into the project. It's just to the west a little bit of Lake Granby. And then the Fraser River is also important to the Windy Gap project, which Northern Water also operates. The Windy Gap project, which was built in 1985 to provide additional water to the rapidly growing Front Range of northern Colorado. And it shares some of the CBT project infrastructure. I'll touch on the Windy Gap project a little bit more in a few slides because it was more relevant this year than in some other years. So in the past 4 years, we've incorporated ASO data into our forecasting models, and we've used it in combination with some other snow and forecasting products and models to plan our operations. The ASO data has given us some more confidence in and insights into our forecast so far, and it gives us many opportunities for analysis. So these are some examples of decision support applications of the ASO data at Northern Water. So reservoir operations, I think a lot of us deal with this. So deciding whether and when to pump water to avoid unnecessary pumping costs, but to get the water where we need it to be. Deciding when to make preemptive releases to avoid flooding, optimizing deliveries to the east slope. And then setting our annual CBT quota. The CBT quota is set by our board at their April board meeting, and it determines how much water is allocated to each water user. And then also optimizing power generation, so timing our Adams Tunnel operations to optimize power generation on the east slope. And then the ASO data can also provide benefits in the form of better understanding our watersheds and their hydrology. So Northern Water has had flights since 2022. We had 2 flights per year in 2022 and 2023 in the West Slope basins. So our West Slope basins where we do our flights are shown in this map. The light blue shaded area, it's the Colorado River headwaters. We sort of divide that into 3 sub-basins. You can kind of see the lines between them, but one is the inflows to Lake Granby. Another is Willow Creek inflows into Willow Creek Reservoir. And another is Fraser River, which is useful for the Windy Gap project. So we had 2 flights a year in 2022 and 2023. And then a couple of years ago, we were awarded a grant from Reclamation to partially fund these West Slope flights. So we were able to add a 3rd flight, and this 3-year project goes from 2024 to 2026. And we're doing 3 flights a year in the Granby, Willow Creek, and Fraser basins. And these 3 flights ideally include one in late March to inform our April 1st forecast, and then one in mid to late April to capture the near peak SWE, and then one in May to capture higher elevation snow data when much of the snow at the SNOTEL stations has melted. So we've completed the 2nd year of the project. 2024, we were able to get late March, mid-April, and then late May flights. This year, our first flight was a little delayed, so we got one in early April, one in late April, and then one in late May. So our ASO data is integrated with forecasts in a few different ways. Those include CBRFC experimental forecasts, WRF hydro forecasts with ASO data assimilation, and then integration with Northern Water's in-house streamflow forecasting models and procedures. And there's also the potential for research projects and experimentation with other forecasting models and snow products and things that we're always interested in. So now I'll focus on this year, and I'm going to focus on the Granby Basin for this presentation because it's what I've done the most analysis on for this year, and because it is such an important part of a CBT project, and it also impacts the Windy Gap project as well. So in 2025, we had average peak SWE, so about 100% average, or 100% of the average peak SWE in this basin, but it peaked about 2 weeks early on around April 8th versus April 23rd. This is generally basin-wide SWE. And then after that peak, we had about 77% of average precipitation in April through July. And during that same period, we had above average temperatures. So we actually ended up with below average natural flows, despite having around our average peak SWE. So our April through July, our seasonal natural flows were about 199,000 acre feet, which is only 74% of average. So just a quick look at this year compared to last year. The black is this year, the green is last year. The solid line is SNODAS. We don't use SNODAS too much in our forecasting, and it shows less snow than all of the other snow measures that we use. But I used it in this graph because it gives a good idea of the shape of the accumulation and melt curve. And then the dotted line is our total observed seasonal natural flow from April through July. So that number that we're trying to forecast. And then the dots show the ASO flights and the total SWE for the Granby Basin that was observed during those flights. So again, we didn't get a late March flight, but we were able to get an early April flight in 2025. And the April flights in 2024 and 2025 were about a little less than a week apart, and they had very similar amounts of snow. So in 2025, we had 225,000 acre feet. 24, we had 220,000 acre feet. But 2025 peaked much earlier, and 2024 peaked much later. It was actually a much later than average peak in 2024. The average is somewhere between 25 and 24. And then the total runoff ended up being very different between the 2 years because of that later peak, or the difference in peak timing and the precipitation and other factors in those years. We ended up with, like I said, in 2025, we had only 74% of average runoff, whereas in 2024, we had 245,000 acre feet, which is 108% of average for the seasonal runoff. Looking at only the ASO SWE values, so this is not real runoff efficiency, but just efficiency based solely on the ASO SWE values from the April 8th, 2025 and April 14th, 2024 flights. We ended up with 111% runoff efficiency in 2024 compared with 88% runoff efficiency in 2025, which makes sense when you look at the April through July precipitation in those years, which was significantly lower in 2025. So now I just wanted to go through sort of the timing of this year and how ASO data helped us with some decision-making points. So I'll just walk you through this graph at first. The blue line is the CBRC model guidance, not the official forecast, but the model guidance. And then the black line is the total seasonal observed flow, April through July. And then the green diamonds are the ASO flights and the total SWE volume from those flights. The yellow triangles are the ASO SWE volumes from those flights added to the flow to date starting April 1st. So we don't have that for the April flight because that was very close to April 1st. But like for that end of April flight, you can see there's a yellow triangle. And that just shows, from April 1st to April 28th, because this flight was on the 29th. And it just shows the flow to date plus the SWE from the ASO flight. And then the same for the May flight there. And you can see that those yellow triangles actually got us pretty close to the actual observed April through July seasonal flow for 2025, which was helpful this year. And then the orange circles are the WRF hydro forecasts. They started off strong, but kept increasing throughout the season. So we'll have to work on adjusting those. The blue circles are the CBRC experimental forecasts that incorporate the ASO data. And then the red circles are Northern Waters physical model that incorporates the ASO data. So like I said, our approximate basin-wide peak SWE date was on April 8th. And then, and luckily we actually ended up capturing close to peak SWE with that first flight, because like I said, it was supposed to happen earlier in late March. So it actually ended up giving us close to that peak SWE value, because we did end up having to delay that flight. So that was helpful this year, though it didn't help with some of our timing. It helped us get the peak SWE. So I'll dive more into the forecast later, but for now I want to focus on a couple operational decision points when we used the ASO data. So the first one was our April board meeting on April 10th, and that is when our board sets the annual quota. Again, that's at their April board meeting. So the quota it determines how much water is allocated to each CBT user. And the board takes a lot of different things into account. Some important considerations are that the CBT water is a supplemental supply. So they consider the supply conditions. So what the conditions are like on the west slope, that includes the streamflow forecast, reservoir storage, a lot of things. And then they also consider the district conditions, so the conditions on the east slope where the water will be delivered. So those are kind of the main things that go into that CBT quota. And it's at the board's discretion. But we use our streamflow forecasts and ASO data and everything we can to help them, to help inform that decision. Since we weren't able to get the flight until April, we weren't able to use the ASO data for our annual symposium or for our April 1st forecast, but we did get the data on April 9th, the day before the board meeting, thanks to a quick turnaround from the ASO team. So that was really appreciated. So we had it in time to do some analysis before the April board meeting. So the ASO flight and the forecast that incorporated the data generally indicated less snow than we expected. That wasn't true for the CBRC. For this first flight, it actually increased their model guidance slightly, but it did decrease our model guidance for Northern Waters forecast. And also the WRF hydro forecast was lower than we expected. So those things, among others, were taken into consideration. And the board considered a lot of factors, but they did decide to be a little bit more conservative in setting the quota at this board meeting. And then the next one was planning windy gap pumping in mid-June. So that was about 10 days after the last flight. And earlier I mentioned the windy gap pumping, or the windy gap project, which Northern Water operates in addition to the CBT project. And so this project consists of a 255 acre-foot reservoir. You can see it on this little map. And it collects water from the Colorado River downstream of the confluence with the Fraser. This 255 acre-foot reservoir is not nearly enough space to store water for the Windy Gap project, so it shares infrastructure with the CBT project. The water is pumped up to Lake Granby. And then it's delivered from Lake Granby to water users through the CBT system. So there are two problems with this project. The first is that it's a fairly junior right, so it doesn't yield much, if at all, in dry years. But then also in wet years, since it doesn't have any storage or more than 255 acre feet of storage of its own, it's the first to spill out of Granby. So we can end up wasting costs of pumping the Windy Gap into Granby if we don't end up having room for it later in the season. So a new reservoir has been in the works for a while and is almost completed. But in the meantime, we've had to carefully assess how much windy gap water to pump to Granby, because we want to pump as much water as possible so it can be used. But we don't want it to spill, because then we've paid for water that can't be used. And in some years this can be a struggle, like this year. The CBT project was in good shape storage-wise, but inflows were a little bit lower than expected. So there was some space in Granby for windy gap water. And then at the same time, the Fraser had a good year, so we were able to use our windy gap rights. So in mid-June, we had to decide when to stop pumping windy gap and how much to pump each day to kind of hit that perfect point of filling with enough windy gap water, but not making Granby spill. So the ASO informed forecasts and the ASO plus flow estimates, flow to date estimates came out lower than some of the other forecast guidance that we had, and that helped to inform the decision of how and when to ramp down windy gap pumping. So we ended up falling a little bit short of Granby's capacity, but we did not spill any. So we're generally pretty happy with that result. Lastly, I just wanted to show you some of the forecasts with and without the ASO data. Again, this is just for the Granby Basin. This does not include all of the forecasts. There are a lot more forecasts that we look at, but I just wanted to focus on a couple with and without the ASO data. So the black line is our seasonal observed stream flow. The orange is Northern Waters model. The circles are the model without the ASO data, and then the triangles are with the ASO data incorporated. And then the blue is the CBRFC model, and again the circles are without the ASO data, and the triangles and the dotted line are with the ASO data. I don't have the Northern Water model results from May, unfortunately, but I have them for April and June. And so we can see, starting with the April 7th flight, for the Northern Water model, it did decrease our model guidance, which ended up being closer to the observed seasonal flows that we saw. CBRC's guidance increased slightly with the ASO data. And then in May, the CBRC guidance increased again with the ASO data, but more significantly. And though it overshot the actual observed flows, it was closer to the observed flows than the original model guidance. And then for the last flight, the Northern Water model, when we incorporated the ASO data, it went in the right direction, but it overshot it. And so it was a little bit farther away from our actual observed flows, but it did give us a little bit of, it made us aware that there might be less inflow than we expected from the model. And then with the CBRFC model guidance, it did decrease that slightly. The ASO data decreased that model guidance slightly, and did bring it a little bit closer to the actual observed flows. So that's what we saw in 2025. So though the ASO data didn't result in the most skillful forecast every single time, it did usually move the forecasts in the right direction, and it often did get us closer to the actual observed flows. That's all I have. Thank you for having me. Unfortunately, I do have to run to another meeting, but please, if you have questions or want to talk about any of this, please contact me. My email is there. It's my first initial and last name, ecarbone@northernwater.org. Thank you so much for having me.
Thanks so much, Emily. Really appreciate you joining us remotely. Next up, we have two back-to-back presentations about our Growing Utah program. First, we have Lily Bosworth, staff engineer with Colorado River Authority of Utah, and Scott McGettigan, the engineering manager for the water efficiency and technology section at the Utah Division of Water Resources, to talk about the two Utah projects.
Thanks, Kate. Okay, I'll dive in. I think we're both going to introduce our agencies and talk about how they're similar and different, and then our projects. So first, before I even talk about our agencies, I do want to just give a shout out to the Utah partners that we have. We're still pretty early in terms of using ASO in Utah, but we've had overwhelming support. So our funding sources are on the top row. And then on the second row, we have technical partners. So I want to shout out LRE Water, who is helping manage the Flakes, Flights, and Forecasts project. Our NRCS partners, the Utah Snow Survey, has been really, really great in terms of helping us with ground truthing this data and coordinating. And then Precision Water Resources, you'll hear from in a minute. And we also had a lot of just general support. We received a SNOFO grant and had a lot of sort of wide-ranging holistic support from different Utah entities. So I wanted to say thanks to them. So introducing just the Colorado River Authority of Utah, we're sort of a unique state agency. So I like to talk about who we are and what we do in general. Our mission is to protect, conserve, use, and develop Utah's waters of the Colorado River system. It's very broad. We are a really new agency. Our legislature created us in 2021. And so we have a 7-member board, and then we have 5 advisory councils with about 52 members total that advise our board. So we have a lot of people that we have under our umbrella advising our work. And with that sort of team of people guiding what we do, we've developed a 5-year Colorado River management plan with 3 priority areas: measurement, hydrology, and operations, and drought mitigation. And those areas all inform each other, obviously. And we think of our project, Flakes, Spikes, and Forecasts, as fitting into hydrology and operations. Obviously, there's a measurement component, but really we're interested in using that measurement data to see how we can integrate it into operations and eventually drought mitigation. Pass it to Scott.
All right, thanks, Lily. So I work for the Utah Division of Water Resources, and as you can see, our mission isn't too far different from what Lily's is. We focus on plan, conserve, and develop and protect Utah's water resources. Lily's end of things focuses more on the Colorado River. We're kind of the whole state, but we still coordinate with the Colorado River Authority of Utah. So, so as Lily said, Utah's just barely starting to dip our toes in the waters of ASO and getting familiar with it. And so we're kind of infants or toddlers when it comes to some of this experience that compared to the experience that some of you all have with working with ASO data. So we actually probably have more to learn from you, but I'm here to present nonetheless. So, but I'm grateful for this opportunity. So I'll tell you a little bit about the project that we have that I just got started here pretty recently. It's the Wings Over Weber project. As you can see, there's a competition between Lily and I in naming our projects. She started with Flakes, Flights, and Forecasts, and I'm like, well, not to be outdone, we got to be Wings Over Weber. So we like, is it alliteration? I can't remember if that's the right thing. But all right, so some of the goals we have when we first started thinking about doing ASO in well, not necessarily in Utah, but because the Colorado River project was first, but kind of moving beyond, to start doing other projects in Utah, we were thinking about what our goals are, and we wanted to focus on the Great Salt Lake Basin. And as I mentioned in our Q&A after the panel yesterday, that it's a big concern for the state of Utah right now is the declining levels of the Great Salt Lake. So we wanted to focus on that, and we wanted to obviously we're new to this, so some of these things may obviously make sense. We wanted to evaluate the benefits and costs that you could achieve with an ASO project and explore new technology and opportunities. We like to think we're on the cutting edge in Utah, but we're obviously a little bit behind some of you all. So we still feel like maybe we're a little bit cutting edge when it comes to this, though, because there's some other states that still need to get rolling on ASO projects. And we just wanted to understand the impacts of variability in snow water equivalent and how that can influence water management decisions and how, and there's just a lot of things that we need to discover, I guess. All right, so the Great Salt Lake Basin, it's no small basin. And as we were evaluating options as to where we want to go with exploring ASO in the Great Salt Lake area, we had these 4 primary areas that we could focus on. And I'm sorry if you're not familiar with geography of Utah, I don't have anything to really help you understand where all these are. But we first looked at well, I wouldn't say the order, but we looked at the Utah Lake Basin, which is upstream of the Jordan River Basin. And we thought that could be interesting, that it was really tied closely to the Colorado River project, because there's diversions that come into that the Central Utah project, and we thought that might be interesting, but we also thought maybe maybe we want to be a little bit disconnected from the Colorado River project a little bit more. So for that reason, we kind of eliminated that one, and not that it was bad. None of these are bad. These are just kind of the choices we made. So we took that one out, and then we thought about maybe the Jordan River. It's a little bit smaller. There's not like a big reservoir that's really interesting to operate there. So we kind of nixed that one. The Bear River is a large river basin. If you're familiar with that, that's a very interesting river system in which the start isn't too far from the beginning of the headwaters, or isn't too far from the terminal location of the Bear River. The trick with this is it's just such a large system, it was hard to narrow it down to one location that really made sense. And so we eliminated that one, and then we ended up with the Weber. We thought that was a nice size to fit our first step into this direction. And this is the Weber River has its headwaters in the Uinta Mountains on the western side of the Uinta Mountains, and I'll give a little more stats on that next. But we didn't want to do the whole Weber River Basin because that's rather large. Also, we just focused in on this upper headwaters section of the main Weber River, which has 2 branches: the Ogden and the Weber, which converge at the end to be the full Weber River Basin. And you can see there's 3 reservoirs in this area that we're going to be looking at and evaluating. And just some stats here. The basin, the Great Salt Lake Basin as a whole, is 21,000 square miles. So like I said, it's no small basin. It's closed basin. And we had a historic low in 2022 of 4188.5 feet in elevation. And that was raised some significant concerns with the public health and with the environmental aspects around the lake. And that spurred a lot of activity, a lot of legislation to try and address the concerns we're facing, the issues we're facing there with the Great Salt Lake Basin. So the Weber River, narrowing down on that's 22,400 square miles and contributes 12% of the flow to the Great Salt Lake. We have 8 reservoirs in that system that are primarily operated by the Weber Basin Water Conservancy District. And then we have a project area of just over 800 square miles. I can't remember precisely. And we think there's about 5 snow-tell sites within the boundaries. That might have been off, I'm not sure. But that just, again, that's a small number compared to what the information you really need to know. And as I mentioned, the headwaters are in the Uinta Mountains. So we also, part of the reason we jumped on this is that we wanted to apply for federal funding through the SNOFO program. We did that in May of 2024. We were awarded 50% of approximately $2 million project. And that was an award in the fall of 2024, and that's important coming up here in a second. We found some partners that were funding partners: Weber Basin Water Conservancy District, the Great Salt Lake Commissioner's Office, and of course, the Division of Water Resources. We are all funding partners in this. We had also other parties who were supportive, and some of those were on the list that Lily showed at the beginning. And here is our plan for project timeline. We initially anticipated that we would be able to, or hopeful anyways, that we'd be able to get a snow-free flight in last year around this time, and just the timing with the SNOFO, getting that award doesn't work out great, and we didn't end up doing that. So our first year of flights are going to be a retrospective look at what happened. It won't be in time for an operational evaluation, which is still valuable, and we're glad to have that. But that's what we're dealing with. So we're going to have a total of 2 flights for the first year, 2 flights for the second year in 2026, and then 3 flights for 2027. And we are hoping to get our snow-free flights soon. And a final report in fall of 2027. So I don't really have cool graphs and data to talk about, unfortunately, or fortunately for you, depending on what kind of person you are. But we were pretty excited about our first flight, and we went out and, did we need to measure snow? Probably not, but we wanted to go do it. So we went out there and took a few measurements, and here's our crew out there all enjoying the nice day. We're out there doing this our first day. And next year, I'll just remember it's always 60 years old for Tom, and I'll have some data for you. Thanks.
Thanks, Scott. Okay, I'm going to dig into the Flakes, Flies, and Forecast project now. So very similar to Scott, we had, sort of grant objectives that I will briefly walk through. Very similar to most of the ASO projects, optimizing reservoir operations is a goal of ours. Short and long-term water management decisions, this is really broad, but not just reservoir operations, but thinking about multi-year water supply questions. Environmental protection, drought mitigation and resilience, which will sort of be a focus of the rest of my slides today, and then disseminating results to other watersheds. So I feel like we achieved our objective because we inspired a second project in Utah, but we're hoping to talk with our other sister agencies about where else ASO could be applied in Utah. So as you all are very familiar with, we have well-established ASO methods, measurement, and modeling. And so what our project is striving to do is first compare ASO data with CBRFC and SNOTEL information, and then applying that comparison and the data itself that's produced from this project to first an operational model called the SACS model. You'll hear a lot about this in the presentation right after ours. And then a planning model called the UCRAF model. UCRAF stands for Utah Colorado River Accounting and Forecasting. It's really more of a planning model though, but the F sounded better than a P on the end of that acronym. So really one of our big questions is, can we do the operational improvements that ASO is known for, but could we also see if we can apply this data to drought mitigation? And by drought mitigation, Scott raised this question yesterday, but could we inform water leasing or water transactions in Utah, essentially with the goal of building a sort of savings account of water in our reservoirs to help with Colorado River Compact compliance? So project overview, timeline. This project is a relatively small area in terms of our total headwater area for the Colorado River within Utah, but it has sort of an outsized impact. So the green colors are waters that would naturally flow to the Colorado River, and then the pinkish color is an area that would flow into the Great Salt Lake Basin. And Central Utah Water Conservancy District operates a pretty complicated system of reservoirs and transbasin diversions and tunnels that link several reservoirs in this area together and also link the 2 big basins across the state. So our vision for this project right now is 3 flights per year for 3 years. Last year, we were able to bring LRE water on to help with coordination. And so we have 1 more year of flights remaining. Digging into some specifics about the system itself and how it works. So this is the flight area transposed over this operational area. So you can see upper still water in the upper corner of this image. Upper still water captures water that's tunneled eventually to Strawberry Reservoir. So going back, you can see this little dotted line. That's a tunnel that captures other diversions along the way. And then Strawberry Reservoir has some releases to Starvation Reservoir on the east side of this image, but Strawberry Reservoir also sends most of its water to the Wasatch Front, providing drinking water for about 2 million people there. Hence why we chose that particular area for the project. So starting to look at where we are in year 2, this is just an overview of our measurement flight path Really lovely views and some on-the-ground support from NRCS. So our flight timing was pretty similar. Year 1 and year 2, 2024 in green, 2025 in blue. And really, we were aiming for a peak snow water equivalent flight and then a couple of flights during the runoff. Central Utah Water Conservancy District has sort of a critical decision time in early May for operating their reservoirs. So we are trying to time our flights either in late April or early May to help them make those choices. Year 1 results, data that you were all very familiar with. This, I think someone used sort of the freshman, sophomore, junior analogy. This was our freshman year. We got data, we were really excited about it, and then we had to figure out what to do with that data. So in year 2, we started to actually use those results. We're continuing to refine the WRF hydro model, the ice snowball model, but most importantly, we're integrating the ASO data into Central's internal SACS model. That's the Strawberry Aqueduct Collection System model, which is that whole system that I showed the map of a couple slides back. And we're preparing to integrate into the UCraft model, but we're not quite there yet. So this is really a primer for the next presentation, but an overview of the SACS model. SACS is a riverware-based model, so typically Central takes a CBRFC forecast at several points and inputs those forecasts into this riverware model and then makes reservoir operations decisions based on that. So we are testing inputs of ASO data into the SACS model directly. CBRFC also created ASO-informed forecasts. So we've also tested input of those into the SACS model. So we have sort of 3 versions of data that we can look at within the SACS model right now. The downside with the CBRFC data in this area is that Central doesn't get a forecast from CBRFC for every point they would like. And so ASO helps us do some gap filling and then supplement places where we do have CBRFC forecasts. One theme that I did want to highlight today is just dealing with interannual variability. I think that's a theme we've covered a lot so far in the workshop, but it's something that the ASO data is proving to be really useful for in Utah. So this is a lovely slide showing the difference between 2024 and 2025 snowpack. And this is a similar slide for our May flight across the whole study area. So a more brown is less snow in 2025 than 2024. You'll see there's an extra dark patch right in the middle. We happen to have a fire summer 2024 after our first set of flights. We were glad we had a baseline set of flights before this fire. But that fire then impacted Central's operational decisions. So they decided to basically close 2 diversion points that enter the SACS system. Those are called the Wynn and Rhodes diversions, and they plated over the diversions so that they didn't get clogging in their tunnels of ash and debris. And with that, we decided to test a drought mitigation question we've been really curious about in Utah. So Wynn and Rhodes typically goes to Strawberry Reservoir and goes to the Wasatch Front through a transbasin diversion. But this year, because Central was already going to forgo that water, we decided to test just letting that water take its natural course, enter Starvation Reservoir, and continue on to the Colorado River and possibly Lake Powell. That water is really high up in the system. So one question we have is, can we shepherd that water from the headwaters all the way through to Lake Powell someday? Can we model that? One really important note is that it's a junior water right. And so the annual yield on that water can vary. It's up to 4,500 acre feet of water. But this year, due to the dry year, we only saw about 890 acre feet of water. So as we're thinking about developing conservation programs, understanding what a water right might yield on a given year is really critical. Central donated this water for a pilot test, but if we were compensating folks for their water, for example, when farmers are fallowing fields, it would be really critical to know if they might be fallowing anyway, if we're paying for wet water using taxpayer funds, or if, we're actually going to get what we paid for. So that brings us to the UCRAF model, which is the other place that we are hoping to apply our ASO data. So UCRAF, again, is a planning model where it has two components. The first is the diversion runoff calculator. You have a sort of schematic on the top right of the screen where we're pulling water rights data, place of use and priority data, as well as open ET data. So we know how much water fields are consuming and canals are consuming. That is connected with a different riverware model that would then help us project and route any saved water through a system. So the goal here with ASO data would be basically to say, okay, if a conservation action is taken in an area, and we have the UCRAF model to tell us how much water, based on historical traces, we might get from that particular location on that particular system and water right, then eventually we could see the outflow. But then ASO could help us choose maybe a historical trace right now to tell us what we might realistically get for that given hydrologic year, if it's a wet year or a dry year. And then we can make really informed investments in terms of drought mitigation. So we're not drying up fields unnecessarily, we're maximizing the use of funds to compensate people for those actions. So that's where we're hoping to go, but not quite there yet. So that's all I have today. Thank you.
Thank you, Lily and Scott. Moving on to our next presentation, which is tightly linked with the one we just heard. We will be hearing from Leland Dorchester and Tony Powell from Precision Water Resource Engineering. Leland is a water resources engineer, and Tony Powell is a project manager for PWRE.
Okay, yes, thanks for the introduction, Kate. Again, I'm a water resources engineer with Precision Water Resources Engineering. We're a consulting firm based out of Leland, Colorado, and as of recently, Salt Lake City, Utah. And we've been working on a project that Lily kind of queued us up for, to incorporate ASO-informed hydrology into the Strawberry Aqueduct collection system operations model. This is an effort that is co-funded by the authority and Central, but we are, as Precision, we're supporting this effort through Central Utah Water Conservancy District. So I just want to kind of queue up and set the stage of who Central is. They are a conservancy district in Utah that operate infrastructure in northern and eastern Utah. This includes the SACS system, that's the Strawberry Aqueduct and Collection System. And the SACS system is just a piece of the greater storage that is part of Central's storage system. So, this figure here shows that there's approximately 400,000 acre feet of water that's stored every year. Of that, there are contracts to deliver 161,000 acre feet of water from the SACS system to the Wasatch Front. When they deliver that water, they're delivering water to around 2 million people. So this figure is a little bit dated just due to population growth. But yeah, just to kind of set the stage of who Central are, or who Central is. So the Strawberry Aqueduct and Collection System, you guys saw this figure in the last presentation. This is a diagram of the SACS system and how it is related to the Diamond Fork and Utah Lake system. This green line here indicates the divide between the Great Basin and the Colorado River Basin. Utah Lake here, if you're not familiar geographically with the area, the north shore of it is approximately 28 miles south of Salt Lake City. So everything to the right of the green line then, like I said, is the Colorado River Basin, and also includes the SACS system. One kind of important thing to note is there's no spillway on Strawberry Reservoir. I'll kind of get to why that's important, but basically Strawberry Reservoir kind of serves as, I guess, the pivot point on whether or not to send water to the Great Basin or to the Colorado River Basin. And then the last, I guess, kind of fun fact I want to share is that, Central can deliver water all the way up to the southern edge of Salt Lake City from Upper Stillwater Reservoir without any pumping. So it's quite a ways for water to go without any pumping. So I just want to highlight the major reservoirs that are part of the SACS model. There's Upper Stillwater Reservoir, Current Creek Reservoir, Strawberry Reservoir, and Starvation Reservoir. Kind of like Lily said, water is transported through a series of tunnels and down to Strawberry Reservoir. And as I said, this is basically the pivot point where water can go down the ULS system or down the Strawberry River. So water basically follows the flow or the direction of these arrows here. So how does this relate to ASO? You know, why are we at the ASO conference? There's a question on whether or not, or I guess how ASO informed forecasts support reservoir operations in the Uinta Basin. So flakes, and forecasts, this is part of the larger project that Lily described. The SACS model is just a piece of the greater effort that's going on in Utah to utilize ASO data. This is probably going to be reviewed for most people in the room, but I wanted to just kind of highlight the connection between the different data sets and models, because I think it's pretty unique, and it's pretty interesting to see that it's, you know, roughly operational only within 2 years. So we've got the flight showing ASO data being collected, you know, those LiDAR surveys collecting snow depth, et cetera. That's plugged into the ice snowball model to create the SWE data set, which is fed to the WRF hydro model. This last step with Riverware is the software that we are using to build the SACS model, or it's already been built, but it's the software that runs the SACS model. And this is where, you know, we as Precision kind of key into the whole process. We're taking these WRF hydro data sets and plugging them into the Riverware model. So the 4 main reservoirs, I've mentioned their names already, but these are the 4 primary storage reservoirs on the Colorado Riverside that store water for Central. These are the 4 reservoirs that are in the model. And you'll see that most of the storage is in Strawberry Reservoir. There's some storage in Upper Stillwater and Current Creek. But operationally, really, Upper Stillwater Reservoir and Current Creek kind of serve as just very large diversion dams. They're diverting water down the system into Strawberry Reservoir, again, where it kind of serves as that pivot point on whether or not to send water to the Wasatch Front or down the Colorado River Basin. Starvation Reservoir, you know, in comparison is not that, you know, not quite as big as the combination of the 3 reservoirs upstream. But it was built as a requirement of the Central Utah project in order to make sure that water users who may have been affected by the installation of the SACS system, just making sure that those water users are whole and unimpacted by the SACS system upstream. So I want to talk a little bit about the operational policy in the SACS model. There's a ton of objects on the page, so I'm just going to highlight the key reservoirs one more time. There's Upper Stillwater Reservoir, Current Creek, Strawberry Reservoir, and Starvation Reservoir. And at each of these reservoirs, you know, basically we're trying to capture 3 different operations that Central may be employing in their management of these reservoirs. That'd be fill, delivery, or diversion from those reservoirs. And then lastly, in the model, we're trying to capture diversion logic. This is, you know, areas where natural flow is being diverted out of the basin and into the collection system to be delivered, again, either down to the Wasatch Front or the Colorado River Basin. Lastly, I just want to mention this is all done accounting for water users at Starvation Reservoir. And so I think it's important to note that we're tracking how the physical water is flowing through the system, but we're also tracking different ownerships and types of water in Riverware using Riverware's you know, pre-configured accounting structure. So the last little bit about inputs to the SACS model before we get into some results. The SACS model is actually an accounting and forecasting model. We kind of generally refer to it as the forecasting model, but during, well, I guess first off, it's a daily time step model that runs from the beginning of the Utah water year, so that's November 1st, to the end of the following calendar year. And during the period that is, you know, from the current date or yesterday and back to the beginning of the water year, everything that's being plugged into the model is just observed data to recreate basically the mass balance of the system and what are the different types of paper water, things like that. But then moving into the forecast period, this is where we are implementing the ASO forecasts. So we're running the model over and over based on the WRF hydro outputs to basically create or understand what the possible outcome, what the possible futures might look like for pool elevations or things like that. And so when the operators at Central are using this model, some of the key questions they're trying to answer, which we're hoping ASO, we're trying to understand how ASO helps answer those questions, are given the current storage and a forecast product, what is the likely timing of reservoir storage? And how does that change if releases, ULS diversions, or Strawberry Aqueduct inflows are adjusted? The last little piece of input that I want to talk about for the SACS model is the ASO data that we have as a whole. Throughout the state of Utah, the data that we have so far incorporates 37 forecast locations that are outputs from the WRF hydro model. For the purposes of the SACS model, we pre-process just a handful of those and create 21 input nodes to the SACS model. All right, and then I wanted to show some results from our SACS modeling efforts. There's a ton of information on this page, so I don't expect everyone to look at everything. I'd just direct your eyes to the two plots on the left-hand side of the page. But for your information, this is a page out of the Power BI viewer that we've built for Central. This is the tool that Troy and other operators are using to basically understand operations in the basin. What might the impact be of different changes to operations? And so you'll see, currently we're looking at the May 9th forecast that we ran. You'll see, in the period to the left of the vertical line, all of the ensemble exceedance values are the same. That's because we're looking at an observed data set. And then once we get to the forecast period that we have with the ASO data set, you can see what the range of possible pool elevations are forecasted to be given the ASO inputs to the SACS model. For Stillwater, you can see that possible range of outcomes is pretty wide. In late May, it's above, and it's around 100-foot difference between the minimum and maximum forecasted values. Down low, you can see we've got these figures that show, how the model is handling operational logic. So how we've coded up the model to define diversions under different kind of inflow regimes. And so you can see how that might look, what this basically helps the operators understand in their decision-making process what some of the possible outflows via diversion from their reservoirs might be. And so in doing this, the operators might, go down the system. Getting ahead of myself. They might go down the system and look reservoir to reservoir. I'm going to skip all the way down to Strawberry Reservoir just in the interest of time. So we're looking at two very similar plots here. I would say the more important of the two is pool elevations on Strawberry Reservoir. Again, a really important one to keep an eye on because there's no spillway on Strawberry Reservoir. So this kind of helps them understand what the maximum pool elevations might be, where for 2025, the maximum pool before entering surcharge would be 7602. So you can see that, they were not approaching, based on the ASO inputs, they were not approaching full pool on Strawberry Reservoir. I'm going to skip back to Upper Stillwater Reservoir, and then I'm going to proceed from the May 9th forecast to the May 20th forecast, just because I want to show kind of how these forecasts are evolving as the season goes, and how, operators with Central are basically keeping their eye on the forecast and seeing how the forecasted pool elevations and outflows and things like that are changing as the season progresses. So you can see, going from this May 9th to May 20th forecast, the forecasted pool elevations has tightened up considerably, where, you might expect to see a range of somewhere between 30 and 40 feet, depending on what time of year you're looking at. And again, if we just step down the system to Strawberry Reservoir, just to kind of close the loop on this presentation. The max, forecast they might expect to see is around 7599.7. Maybe a couple traces are going up to 7604 or 7600.4 later in the season. The last thing I want to talk about, which Lily mentioned a little bit, is some of the hindcasting work that we've done. So we ran the SACS model using, I guess at this point, 3 types of forecasts. There's the WRF hydro forecast, which I just described. And then there's the CBRC forecast. That's a standard forecast that comes from the CBRC. But then we also we collaborated with the CBRC to have them run the CBRC runoff models, but using the ASO informed snow product. And so when we did that, we got 2 sets of results here. The figures on the left-hand side are also exceedance plots. The red horizontal lines are the full pool elevation for Strawberry Reservoir. The blue clouds represent the minimum to maximum pool elevations you might expect to see under different forecast products, where blue is the experimental forecast and the orange cloud represents the minimum to maximum of the standard CBRC forecast. The 2 correspondingly colored lines represent the median values, and the black line represents what the observed value was throughout the season. Now we run the model in 2 scenarios. We have the nil action, which basically is solving the model without telling it to mitigate against entering surcharge space. And then we run it again in a mitigation configuration where we're solving the model, but we've defined operations to mitigate against entering that surcharge elevation on Strawberry Reservoir. And so when we did that, I mentioned there's 3 methods to kind of control the elevation on Strawberry Reservoir. There's releasing down to the ULS system. There's reducing that diversion from the Strawberry Aqueduct, or there's increasing the releases from the reservoir. And that's shown in these 3 columns here of these 2 tables, where the results from the regular CBRC forecast are shown on the left-hand side, and the results from the experimental forecast are shown on the right-hand side. So you can see that the experimental forecast is just indicating a slightly greater need for mitigation actions. In 2024, this ended up being really important because it was a pretty wet year. It was the 3rd year in Strawberry's history that they filled the reservoir. And the, I guess compared to these tables, the actual diversion to mitigate against entering that surcharge space was 22.5 thousand acre feet. So not too far off what was forecasted in these tables. So the discussion and next steps is really simple from precision's point of view. We just need to collaborate with the ASO team, evaluate forecast development throughout the project cycle. That's everything I had to present. I want to say a special thanks to the whole team that's been involved. Jeff, Dave, Kate, Logan, everyone else at ASO that's behind the scenes that maybe we haven't met yet. You're creating a great product that's been, really interesting to work with. Lily with the authority, Troy with Central Utah Water Conservancy District, he's one of the operators. And lastly, Paige, who's been helping to kind of manage and coordinate between all the teams. With that, I would take any questions if there are some.
Hey, Leland, it's Jeff Deems. I have a question for you and maybe also for Lily, because there's 2 aspects to this. One of the cool things about this particular project is the connection from, improved monitoring of the snowpack and the headwater systems all the way through flow to an operational model with the intent of supporting policy and programmatic implementations in the Colorado River Basin. So it's kind of this full end-to-end implementation. I'm curious to both of you in that context, where are kind of the pinch points that where uncertainty comes into play, either from the programmatic implementation of drought mitigation programs or in the operations model in terms of how the model is allocating different flows and administering water rights, or maybe inverted, what's the impact of uncertainty, or what's the impact of increased confidence in either of those from the programmatic or operational perspective?
Yeah, so we've been looking at it you know, really in a preliminary sense at this stage, you know, we're only at year 2. One big thing of uncertainty, I guess, in the modeling is the difference in assumptions, the underlying assumptions in the models. So, you know, if you compared the CBRC forecast with the WRF hydro forecast, the consumptive use that's kind of baked into the forecast might be a little bit different, and therefore might kind of give a different answer in the operational models. So that's one thing to consider. That's part of the reason that we ran the CBRC experimental forecasts as well as the CBRC forecast, to do kind of a comparison, you know, all the way down the chain from basically a WRF hydro, I guess, pure forecast to the mixed forecast that's the experimental, all the way to the CBRC, to just kind of help evaluate what we're seeing.
I'll jump
Yeah,
in,
hopefully.
Jeff, more on the programmatic
thanks.
side. Hydrology is definitely one of our biggest areas of uncertainty in terms of drought mitigation programs. So the other area of uncertainty is having volunteers to participate, which has nothing to do with data. It has everything to do with who's comfortable even working with the government. So that's a whole other talk, but I'd say that's another thing that we have to really think about. We can use the UCraft model to say this is, you know, maybe the best bang for the buck in terms of location. This is how much water we think we'll get out in a certain year. But if we don't have willing participants, we can't do anything. So that's a very different challenge.
Great. Thank you, Leland. With that, I think we are ready for lunch, and I'm going to hand it back over to Molly.
All right, we're going to move into our afternoon portion of today. We've got a few great talks, and then we have a modeling panel and discussion. So yeah, I'll give it to Kate.
Thanks. All right, we're going to kick it off with Noah Molotch from the Institute of Arctic and Alpine Research at the University of Colorado Boulder. Take it away.
Right. Am I talking to this? Okay, great. Thank you so much. And great. Thank you for the introduction. The title for my talk is Process-Based Controls on Snow Water Equivalent Distribution Inferred with ASO Data, Machine Learning, and Physiography. And the talk is one that is different than what I typically do for this cohort at the ASO meeting, and that normally I'm talking about operational work that we do. But the storyline that I'm going to tell is really following this path of a very pragmatic goal to extend ASO data in space for bias correcting my team's real-time snow water equivalent model. But through that, discovering that patterns that were emerging in our data were suggestive of new process-based understanding that really made me reflect on some of my earliest experience in studying snow that I'll mention here in a moment. So the objective here is to use a deep learning convolutional neural network to identify basins with similar relationships between snow water equivalent and physiography. And this leverages ASO data within our existing workflows for our snow water equivalent product, which uses ASO data to bias correct the model. And it's also helping us to identify new workflows, given the ASO sampling strategy in California and Colorado, which has become quite widespread. And so here's kind of where the story starts, which is the maps that are shown here represent the difference between my team's modeled snow water equivalent, which I won't go into detail in this talk on what's behind that, and ASO. And so the basins are labeled with the dates at which the ASO was acquired. And when you look at just the whole image in entirety, what you see is that about every 2 to 3 weeks, we have a new ASO flight to have an understanding of where our model errors are and to bias correct those model errors and carry them forward in time. But what you also see is that there are basins that are missing, and any of the basins that are shown for any given day, right, could be thought of as potentially missing, where you know, it's anyone's guess when we think of ASO data as becoming sort of stale or outdated with regard to current conditions. And obviously that depends on if there's been recent snowfall. But nevertheless, for those of us that want to utilize ASO data to improve other models, we want to develop a way to kind of fill in the gaps. And so the picture here relates to how we're going to go about filling in the gaps, whether it's for our Colorado domain or the domain in California, and all brought into this sort of regional context, which we're now modeling operationally for the U.S. Bureau of Reclamation over the entire West. The question is, how do we utilize the ASO data in an elegant way to estimate the SWE over larger areas? And given that I know a lot of it's been said, I wasn't here yesterday about Tom's 60th birthday, but this is my slide, that the puzzle of snow distribution, an ode to Tom and the ASO team. So the things that have been prominent on my mind this week and coming here have been Tom, and also this puzzle that I was trying to do with my kids over the weekend of Santa Barbara. And there's actually a synergy here between thinking about the patterns of SWE that ASO samples across the ground and how that can be used within machine learning and deep learning frameworks, and how a human being considers information within a puzzle piece to then model how those pieces should go together and to identify how one can see one piece versus another. And it made me reflect on what the puzzle piece looked like when I met Tom. So my first paper that I ever published was based on snow surveys from the Tocopah Basin in the southern Sierra Nevada in 1997, a project that Tom was instrumental on. And it also utilized Landsat enhanced thematic mapper data that was based on an algorithm that Jeff Dozier and Walter Rosenthal had developed and had just published the year before I met Tom in 1998. And I know that that paper and those two individuals were really impactful in terms of what Tom has done and what the ASO team has done with Tom to bring us to where we are now, where the look at the puzzle is now so much more complete than it was then. And it really makes me feel old to think that at that time, MODIS was an instrument that was forthcoming. We were excited for the launch of MODIS, which now has a 25-year record. Tom was working on algorithms from Avarice and from Landsat data that would later be extended to MODIS. And I was working on these regression trees to utilize those point measurements that are shown with the dots on that 19 square kilometer watershed to build a regression tree model that basically is like building a puzzle of a watershed SWE distribution pattern, where those rectangular nodes that represent snow depth in centimeters, there's 7 of them on the regression tree. That's the number of basically colors or patterns in the puzzle. And so now when we think about a puzzle that might look like the intricate red tile roofs of the city of Santa Barbara, which I'm trying to put together over the weekend instead of working on my talk. We all need a good distraction from our work. And what do I look at when I'm trying to put together those pieces are the stripes of the green lawn in front of the mission, right? Just the minutia of detail that allows me to model in my mind what puzzle piece might fit next to that piece that I'm looking at. Versus what we were doing in the late 90s and early 2000s from point measurements, the idea being that if I could only see one color and not its relationship to adjacent colors, how could I possibly be able to recover the pattern that exists across the landscape? And of course I couldn't. And so the enterprise of all of you in this room, right, is that not only have we developed the ability to see that pattern in detail, to see it morphing through time, right? This static image, this static puzzle, in the case of snow, is an evolving landscape of snow cover patterns and relations to the topography in the landscape. And so that's where we get into the technical aspect of my talk, which is the use of convolutional neural networks to pull ASO data together and relate the sweep patterns observed from ASO data to a number of independent variables or features across the landscape. The details of those features I won't go into here, but the convolutional neural network is very much like the approach taken here to solving the puzzle that's shown. And that when you start with all the pieces that haven't been put together, what you do is you say, let me take all the windows. So zooming in, which is the first convolution piece on 3x3 windows within the image, let me identify features in this space of 3x3. And in the case of the puzzle, I'm saying, oh, I'm seeing windows. So let me put all of those windows and pool them while maintaining the detail in the information and create piles of all the puzzle pieces that have windows, and repeating that for all those that have palm trees and all of those that have trim. This was my weekend, right? Was staring at pieces of trim and windows. And of course, the kids went back to their phones, and then it was just me working on the puzzle. Okay, so all of this, then what I learned from this in the context of convolutional neural networks is that the longer I stared at these puzzle pieces, the better I learned about the relational information inherent on each piece. The human eye using color, like we see in the case of the green lawn here in the puzzle pieces, but all of those features and all the feature space that exists that we can derive from other sources of information like digital elevation models, fractional snow covered area detected from satellite, and other various metrics allows us to model which puzzle pieces are going to fit together, which is effectively the exercise that we want to do in terms of filling in the gaps in the ASO acquisitions for bias correction. So some of it works horribly, okay? So I want to start with that, okay? And sometimes you get lucky. And what's fun about this is to find out the cases where it works well and then ask why did it work well in that case. And so here's an example I'll show. So ASO acquisitions from earlier this year across the Front Range of Colorado. And what we could do here is, for argument's sake, let's say we take out the Clear Creek watershed and try to model that based on the observations from the South Platte and from Boulder Creek. And that might be similar to what we might do in California, where we've got gaps and we try to model the American River Basin from the Tuolumne or the Truckee. And so in the case of the Clear Creek example, the output from the convolutional neural network model is shown on the left. The observations from ASO is shown on the right. And on the far right scatter plot, where you've got CNN on the vertical axis and ASO on the horizontal axis, you can see here's an example where it works fairly well. And for those of you that know this part of the country well, you'd say, well, yeah, that kind of makes sense. Similar climatology, similar side of the continental divide, close proximity in space, so exposed to similar storms. So if we're thinking about the good, the bad, the ugly here, this is the good. All right, but then we might consider an example where let's get crazy. Let's go to Crazy Town, okay? And let's try to model the Uinta Mountains of Utah here on the top left from data from ASO collected in the Roaring Fork and in the St. Vrain left-hand watersheds here on the lower right. And when you do that, you can see the errors have gone up. There's quite a bit of spread there. Don't be fooled by how close they look to the one-to-one line, right? If you looked at the percent error in a lot of those points, it would be quite high. But when I saw this, I said, well, that works pretty well considering that it was Crazy Town to begin with, to try to model SWE in Utah from these basins in Colorado that we wouldn't necessarily think would be similar. So it begs the question then, like, is proximity important? So in elevation space or in physiographic space or in the snow distribution space, some of these places may be closer to one another than basins that are immediately adjacent to themselves. Okay, so proximity may not be that important. Case in point, okay, so here, let's model the Roaring Fork watershed from data collected in the Blue River, which is relatively close, and the Yampa River Basin, and now look at the scatter plot on the top right, right? So this is sort of the bad, or maybe we could call it the ugly. It just doesn't perform adequately, and I've got the word useless up there because arguably one might consider that it is. I'm not going to show you all the cases here, but what we found when we started doing this exercise on the different data sets, and I should have said at the beginning, this is all work done by Emma Tyrell, so what she found, I should say, is that there's emerging out of this an approach where basins with similar physiography seem to be able to model each other better than those that don't. And it really reflects on, I think, what we might consider to be the holy grail of snow hydrology now that ASO has solved the first holy grail of SWE distribution, right? I would argue the new holy grail is spatial transferability of relationships between SWE and land surface characteristics. Temporal transferability has been proven time and again for decades. Spatial transferability has eluded the snow science community since we began collecting spatial snow data. And I think ASO data is potentially the pathway toward that. So imagine histograms of a test basin, which are shown for slope at the top row, elevation at the bottom row, and aspect in the rows plots on the bottom. And then imagine those histograms for test basins and training basins, and using the naked eye, just sort of trying to picture basins that would exhibit similar histograms. One can actually derive indices of histogram similarity, in this case using a Jacquard similarity coefficient, where if you overlay those histograms, which are shown here for the two training sets in yellow and blue, and the test set in black, where you've got aspect on the bottom right, slope on the bottom left, and elevation on the top right, then one can start to really visualize how similar different watersheds are from one another. And by doing that, we start to evoke what are the processes that are dominating snow distribution in these different watersheds. We would come up with a different interpretation depending on which features are proving most prominent in terms of similarity leading to model accuracy. And so here's a result where we can look at, on the vertical axis, the RMSE of the CNN model applied to different training with different pairs of training sets and test sets. So that's on the vertical axis of how well could we model the SWE. And on the horizontal axis is the similarity score increasing from left to right. So as the similarity in this Jacquard similarity index increases from left to right, what we tend to see is the RMSE of the modeling go down. Okay, so this then leads to a sort of a workflow where we can think of, a given set of acquisitions from ASO, where we want to use information from ASO to bias correct our regional SWE model. We've got some watersheds where we don't have ASO data, or maybe we consider that data maybe outdated because of a recent snowstorm. And then we can go into that by grouping different watersheds, finding where we have basins of high similarity that have been measured. We can identify those by using a random forest classification based on the different measures of similarity across over a dozen independent variables. And from that random forest model, we actually learn a lot about the processes that are dominating the snow distribution in these basins that emerge out as being most similar. And then from that, we can then run the convolutional neural network to model the SWE in those basins that we're missing and come up with a more regional scale perspective of this. And so to conclude on the storyline of how we had this relatively pragmatic, very operations-focused goal of needing information on SWE distribution in watersheds that either hadn't been recently flown by ASO or hadn't been flown at all. And emerging out of that and through identifications of similarity in basins, we identify information that relates to the process that controls snow distribution in these different watersheds. And so in many ways, the right-hand side of this loop represents sort of that process knowledge gain that we might get from exploring these basin similarities. And on the left side represents sort of the pragmatic desire to characterize SWE based on ASO at time periods between flights. And with that, I can take questions. Yeah, Tom.
Since you made me feel really old by doing an ode to, it seems to me that, we lost your slide. It seems to me that this is going to be quite seasonally sensitive, that the ablation season is more amenable to this than the accumulation season, because in large part, the ablation season isn't nearly as influenced by synoptics as the accumulation season. And Andrew Hedrick has a paper that speaks to this, just how similar is the distribution from year to year within a single basin, and then within that basin. So can you speak to that?
Yeah, so I didn't mention, but there's, and this might be considered cheating a little bit, but there's ground snow obs, time series of snow sensor data that are used in that similarity index as well. And Emma's nodding her head at me, so I think I'm on the right track with the answer here. That is exactly aimed at trying to bring in a perspective in the deep learning that is not solely rooted in static variables. But if you think about a niveograph, like where are you on the trajectory of the niveograph, which I think is what you're getting at, right? Depending on where you are on the trajectory of the niveograph, you start to lose information from the past, right? Especially if you flip from an accumulation period to yeah, so I think this is somewhere we need to spend more time thinking about how to honor the synoptics as well. Yeah. Although I wonder though if, well, once you guys have built up a catalog of 2 decades of data, right, then I think we start to have even more opportunity. So we have to keep going for another 20 years, Tom. Yeah, we've got a question in the back.
Yeah, we've got one online too. So maybe Ravindra, I think you're unmuted. So why don't you ask your question and then I'll give the mic to Mark.
Is this better? Sweet. Yeah, great talk. Super interesting. I'm curious your thoughts. Maybe you've looked at this, maybe you've not. Maybe I'm sort of thinking about it in the wrong way. But to what extent do you think the basin similarity index might be covering or a factor of station representativeness, right? So could it be a portion of that is that the stations are actually representing that basin in a similar or dissimilar way, rather than the basin characteristics themselves, how well it's being represented?
Yeah, I mean, that could affect just the one similarity metric, which is based on the ground obs. Is that what you mean? Because most of the similarity metrics are based on spatially explicit information that covers the whole watershed.
Right, but then when you're you have you're learning based on those point measurements that may or may not capture that as well? Or am I thinking about that the
No. So this is not the other folks' approach to doing machine learning with ASO data. We don't have any ground snow obs that are sort of going directly into the model in terms of SWE information. It's just modeled based on ASO data only, yes. Yeah. But I thought maybe your question was pertaining to when we're looking at the metric from the ground obs in terms of where we are in the NIVIA graph, just in terms of the similarity index, which we've done in response to Tom's point, then that would come in. But that's solely in the context that it's not involved in the left side of this schematic or step 4 with the CNN. That's only done in terms of identifying potential basins of similarity. And we haven't yet teased out whether or not that SNOTEL metric is really factoring much into this. What we want to do is unpack that random forest and identify, and I actually had a slide on that, but I think it's not on here, which features are most important. And yeah, so it's a small part.
And this question from Ravindra here says, Noah, would you please tell us more about how you are defining the basin similarity index? Is that also considering temporal behavior of a basin?
Yeah. So the similarity index is a numerical evaluation of the overlap shown in these histograms. In addition, which I don't have the one for the SNOTEL on the screen, there is that snow sensor piece where we overlay information from the SNOTEL onto each other. That is the only temporal variable that we have embedded in the process right now. Emma's again shaking her head at me. Yeah. So we need to do more work. I'm sharing this with everyone because these ideas are great. We need to get more ideas from the community on this because we're just starting down this path. And ways to honor the evolution through time, right? And variables that we can incorporate to do that, whether it's on the accumulation and synoptic scale meteorology side, or with regard to snow melt, or where we're at in terms of transitioning from accumulation to melt, are all areas we need to bring in more information on the temporal side.
Awesome. Any more questions?
We got Deems.
Thanks. This may be essentially the question that Ravindra was getting at, but how stable do we expect this to be over time? Like, we see the same basin in different years, or even in the same year, showing dramatically different patterns of SWE. So if we only have the physiography to drive the similarity, like, how stable do we expect that relationship to be?
Yeah, and as Emma was sharing her, the advisor meeting Wednesday afternoon, I'm like all excited to see what this very talented person has done for the week. And I want to see more data points on this graph, right? I want to see a robust indication that with good basin similarity, one can consistently get relatively low RMSE. And what I may not care if we don't get there, because from the process perspective and like having the view that every watershed is a unicorn that needs very explicit measurements within the watershed. I'm preaching to the choir on this, right? The idea that maybe there's another unicorn out there. It's like the scene from The Hangover, right? Where they're on the roof in Vegas. And I forgot the actor's name, but he's really weird. And he's like, I was a wolf pack of one, and I thought I would be alone forever. And suddenly there's this other member of the wolf pack, and here you guys are. That's like the viewpoint of like SWE distribution in a watershed, right? Maybe there's another like wolf out there that goes with this other watershed. And so like, I just think that's a cool idea. So I didn't talk about operations as much as I normally do, because I think this is like a cool way just to explore, like, are there watersheds out there that go together? Tom said kind of like quantum entanglement. So thanks for all the questions.
All right, that concludes our talk portion for the day. And I'll bring Gotchis up here to introduce his panel, maybe. He's deep in. Go here, come here.
All right, well, thank you, everyone. That was good stuff. We've got about an hour, right, Molly? Yeah. Before we're going to wrap up for this afternoon and then talk about maybe the revised dinner plans and stuff. Okay. So in that hour, we are going to have a panel discussion. And the panel discussion is in lieu of a number of modeling talks by the modelers. Did some thinking about this coming into this workshop, and there hasn't been a huge new infusion of different models this year. I think there's constant tweaking of the modeling systems and types of forecasts that people are using and drawing into their operations, and that's good. But we've seen talks on many of those, kind of in the spirit of what Noah said. I'm not going to give up and give the same talk again that I've given for the last few years, maybe just with another data point on the end. But instead, what we were thinking might be really useful for the modelers is an engaged discussion with the operators on what is most useful when confronted with a forecast which has uncertainty. And in particular, what is the process, or what is the thinking that an operator decision maker is going through when you've got multiple forecasts that you have to look at and you have to weigh out and make a decision on what you want to do. So that's the high level. I've got about 4 or 5 slides with some framing topics on that. And then I'm going to, I've got a list of questions that we are going to ask our panelists. So feels like the dating game, because we're going to walk these people out with an introduction. So contestant number 1, Scott Fenema, U.S. Water Master. And Scott, as he talked about during his talk yesterday, U.S. Water Master helps manage the Truckee and the Carson systems for the U.S. Water Master's office, and is constantly having to look at many different forecasts and data products by his job description. Next is Andrew Reisling from the California Cooperative Snow Survey Department of Water Resources. As we know, Andrew leads the group that helps develop the B120 forecast, if I get this right, in the Division of Labor within DWR. And he and the rest of his team are constantly looking at a number of different forecasts. And we don't want to steal too much of Devin's thunder, because I think she's going to explain more of this in her talk in the details about how they develop their consensus forecast. But clearly there's a lot of decisions and other background discussions that go into that process that will be useful here. And lastly, and certainly not least, Stephen Ho, who also talked yesterday from the Merced district. And Stephen, as you know, his group at the Merced Basin does use a number of different model forecasts and data products. And together, all these folks have to do consensus forecasting. Now, I did not intentionally leave out Colorado and Utah, so don't give me dirty looks, you guys. There's a couple of reasons why these folks here were up here. We didn't have a lot of Colorado folks here in person, and it's a little hard to be on a panel in person. But for those who are still online and watching, I definitely would love for you folks to chime in, either with your own experiences or with questions for the panel members who are here, as well as you folks from Utah as well. And both of you guys, I know, have a slightly tighter system, it seems. You've got a more unified system instead of tons of different models to look at. But with the ASO grants that you're now using, there's more forecasts coming into the shop and things like that. So would love to hear from you guys as well. Okay, so with that, we are going to go through a few framing slides just to talk about, really what's the challenge here. So in any given day during the forecast season, there are different, I should have waited to call you guys up after this, shouldn't I have? Yeah, that's all right. So there's different forecast models of different types, and we've seen some discussions on some of these. These models all have different strengths and weaknesses. I'm making no judgment calls here on what's better or worse, but in any day, you may have models from these different classes of forecasting systems coming in, ranging from physics-based, highly spatially distributed ice snowbow runs at 50 meters, all the way up to things that are a single unit for an entire watershed, right? Or you could have something in between the conceptual semi-lumped model. I would say the RFC class of models tends to fall into that category, as do several others. There are certainly statistical regression models. There are AIML models, which are, often have a lot of statistics and regression among other mathematical operations in them. And now these days we've got hybrids of those going with like the CW3E LSTM version model, which is running a physical model and then post-process with an LSTM model. So strengths and weaknesses to all these. How do we make sense of that? How do we suss out what we trust at different times? There are the impact of different basin states and the perceived accuracy of how well these models are handling or tracking basin states. Whole host of variables here. Snow water equivalent, soil moisture, some shocking changes in runoff efficiency reported this morning between 2024 and 2025 from multiple basins in Colorado. I think that was super interesting to see. So models or methods that account for antecedent conditions certainly could be on the table. How are those states derived? Is there just sort of a continuous open loop version of model, or is this model actually assimilating real observables as it's getting into its state representation? And then, of course, there are stateless models, which are largely just regression relationships, maybe between forcings and an output or some accumulated anomaly structure. A lot of the statistical anomaly models are more, they don't even really have a state that one is tracking throughout the season. This is where I think there's still a lot of work from the modeling community that we can bring in to help the operators with this. What is the use and value of historical performance? There is nothing like a track record of operational performance, meaning how did you do year over year? But there's a challenge in that. Things change from year to year. You can have a major version upgrade. You could have a major recalibration. You could have major new data assimilation innovation. And so sometimes year over year model performance may not necessarily mean for much, but you like to see that, or you like to see somebody go back and recalibrate and show some hindcasts or simulation results. And so how do folks who are making decisions weigh that? Knowledge of the weather data choices that are going into this. We've seen some wild swings, particularly for the atmospheric river events in California. So knowing which models are ingesting which type of forcing data could certainly be on the table. And then there's the operational and decision points themselves. I go think about what Matt Meadows was talking about in his talk yesterday, or in the panel discussion yesterday, which was, hey, the AJ numbers are great, but I do have a job in between April and July, where I'm actually doing things day by day, and I have to make decisions day by day. So while that number is really good, there's a lot of other decision points throughout the season that we're weighing out. And what is needed from these models, which we like to go look at the AJ numbers, but maybe there's opportunities to give the decision makers more information, more short-term information, more daily time series, more peak flows, more anomaly structures, and things like that. And then lastly is, I think, a bit of, somebody's used the word holy grail. Was it Erik? Was that you this morning? Oh, that was you, Noah. Noah had the holy grail. So I think the other thing in this consensus-based forecasting is there an optimal way to blend forecasts together? We all think that we'd like to see that when we see two different forecasts. Well, just average them and take the one and take the number in the middle. Well, that may or may not be a good idea. If you've got, 150 different ensemble members, some of those ensemble members may not actually be that relevant for the given year you're in, but yet we don't really talk about that much. We look at a 10 and a 90 and we think, maybe we want to shade to one side or the other. But in the processing of these forecasts, there's a lot we could do. We could preferentially weight more of these ensemble members based on climate anomalies, based on recent performance characteristics. You could try to do optimal selection, which is kind of the blending of some new AI methods with ensemble forecasting. And then something we don't talk a lot about, which is scenario based, although we heard some people talk about it, which is like, here I am in 1st of March in California, and I forget what the year was, maybe 2015, it stopped precipitating, right? And in a lot of these forecasts and ensemble forecasts, we usually don't have a no precipitation scenario that we run through it. It's usually just sampling from history, but we do have maybe one member of that, but as that risk-based analysis, maybe as a modeler, we could start putting together and finding ways to display and communicate things like a no precipitation option. So this is just saying that with all these different work going on with different kinds of models and different structures and generating different kinds of information, there is the potential to hopefully provide, I think, not just information, but useful information for folks actually pulling levers and making decisions on that. And I would say it's one of the most common questions we get if we're deeply engaged with the stakeholder group. We'll get an RSC forecast. On our side, we'll get a WRF hydro forecast. And they're like, why are these different? And a lot of times I have to just say, I don't know, because I don't know the intricate details of what goes into every model. I can tell you about what I'm doing. And then, you start a discussion and lo and behold, you can start to identify some commonalities and some differences. So that's kind of laying the groundwork for where we're headed in this discussion. I've got some questions that we'll take some turns on here. And maybe we'll start with Andrew on this one. How does your organization utilize multiple forecasts? And I think maybe just a high level of what's going on in the B120 process, without getting into all the gory details, might be a good start.
Yeah, okay. So yeah, you've demonstrated that graphic 100 times. So you can see, the number of forecasts that we are happy to display to kind of, help anyone who's using this data to kind of get an idea of what might be happening. So, but from our DWR perspective, long term, since decades ago, we've hung our hat on doing the regression equations in-house. And we haven't stopped that. We have collected data with all y'all for 100+ years. And that's one of the beauty of that method, is that we can dive back in and see where this data comes from. Whereas a lot of the new models that we're trying to look at and trying to understand and bring in-house, we may not be able to get under the hood as fast and really understand what's going on and why it's doing what it's doing. And so our commitment is to still stay with that regression because again, we can easily get into it and see maybe if we've made a mistake or if there's reasons why we're missing data that is biasing our forecast. So that's still as of this point where we still hang our hat on. But with all these other wonderful products coming online, we're trying to bring some of those in-house with CW3E and ASO WRF hydro, understand the models, start to see what you guys have been working with for years, and see how those help. But the hope would be is that there's at some point some kind of a consensus, but we're so early in the game to really understand, like you were talking, Dave, about, what are the nuances? There's a lot to talk about there. And so, and we do that, RFC, we are in-house with the California Nevada River Forecast Center, and they used to do regression equations as well. And so we would compare notes and see where we were different. So that's essentially what we're talking about. But they've then gone to an ensemble. And so we're not comparing apples to apples anymore. But we still meet to kind of get an idea. What are you seeing and why are we different? You know, there's been years when we've been quite a bit off. And I know that's frustrating for some of the folks who are looking at both those types of forecasts and trying to make a decision operationally and whatnot. And so we talk and we try and figure it out, but we don't necessarily change our forecasts because it's not definitive that that's, you know, what's right, what's wrong. And over the season, things can change. So I don't know if that's a great start.
Okay. Steven, you want to take a little crack?
Check. We use all of them. And when Dave came up with the new wharf hydro for Merced Basin, I think a year later he came to me and asked, Steven, how did we do? And I had to be honest, like we haven't looked at it much. From a water operator point of view, when you have to make a call, especially in year that are drought or wet, in average year, then we have less excuse. But on an extreme year, we looked at all the products available and we would get them from, you know, Snowdas, Boulder, Wharf Hydro. They are all different. And the thing that I find helps us the most is attending those briefings that DWR host so that I know what the modelers are doing and what are they good at. For example, with CNRFC, one time they said, oh, hey, we're having trouble with our temperature module. So we need to tweak it. So for the next week, don't use our stuff. Those are the type of things that I find the highest value in, because in my district, there's probably just me and one other person who looks at any of the forecasts. And then all I'm doing is filtering all this forecast, all these models into a few, hey boss, it might be A or B. We got to do A or B. So I don't have the time to go through all the fine details of every single model at all times. And that's where, you know, attending the meeting and getting the short version helps. And then later, when we're not so busy, chat back with Dave. I'm like, hey, Dave, I think you know, we would be happy to have a forecast point here. By the way, I need to give you this, and we have this for you to check against later. So those are the continuous improvement. Hope that helps.
Yeah, go ahead, Scott.
Yeah, I'm really glad that you kicked this off in a dating game style, because when it comes to forecasts, there's kind of a dating aspect towards it. So within our basin, in the Truckee-Carson Basin, we are heavy users of the CNRFC's forecast. We use the full ensemble. We run it through our models weekly. We also rely heavily on the statistical-based forecast, whether it's NRCS's or the B120, and we have methods where we can actually blend those two forecasts together. Well, now we're in a new space. We're getting wharf hydro forecasts. If you look at that amazing dashboard, there's a alphabet soup of forecasts that are now available for seasonal forecasts. We need forecast on daily time steps. But before we use a forecast, we have to trust the forecast. And it's really kind of a dating courting session, I guess you can say. And when we take these new forecasts, we first need to learn to understand like the fundamentals behind it. But we also need to know the forecaster to know what their judgment is going into the model so that we can look at the results and see, does this even make sense? We're in this interesting space where we have our tried and true methods that work and give us great operational knowledge, whether we're in flood operations or, you know, managing drought. But as we're adding these new forecasts in, we have to find a way to verify it and get it into a space where we can actually start using it and knowing when to rely on it more. So really, like, how do we use forecasts, especially these new ones? It's kind of like going on a couple first dates, slowly getting to know it, really getting to know our forecasters too as well. That really helps makes the difference. But
Okay, sounds like Scott's a take it slow kind of guy. So, all right. Before we move on to another question, I was wondering if anybody in the audience wanted to throw some comments into that from the operator side in particular. Scott, Lily, nothing yet? Okay. All right, we'll go on to a next one. Let's see. Does model state error or other real-time assessment efforts begin to come into play in affecting your decision on differing forecasts? And this would include things like what we see in assimilation increments now from different models. We've got ASO as a snapshot of truth, but we've got maybe 4 or 5 snow products on the DWR dashboard at any one point in time. Do those increments matter there? What about, are any of the models that you're looking at, are they providing a real-time stream flow time series so you can look and see where the forecast is starting from, so to speak? Has the model been tracking well over the last couple of weeks? Do those real-time assessment efforts factor into how you perceive a given forecast? Scott, go ahead.
Perfect. That's a great question. For the most part, like if we're in an emergency, Stephen truly nailed the nail on a hammer, however that works. But by talking about like, we don't have time to really dive into the nuances of it. So one of the things I think about on your question about like initial model states, during flood operations on the Carson River in the past, one of the things that we'll do is we'll look at kind of model performance over the past 2 weeks for say RFC, and we'll say, how well is it tracking? Is it low? Is it high? And if RFC has been low, then we'll start to look at the higher end of the range of the ensembles, and we'll kind of use it to hone our eye on where we're looking within the spread of the ensembles. And then we also know typically if RFC's been low for a couple weeks or high for a couple weeks, there's probably going to be a correction soon. So we'll be on the lookout for those corrections. But that's on, a day-to-day time step when we're making operational flood decisions of do we spill today or do we hold on for a little bit or do we halfway spill? So initial states help. But when it really comes to the nuts and bolts, we really need to be able to have processes in place to grab those forecasts and put them into our models so that we can make decisions quickly. So as much as we would love to spend time on it, it's hard when you got to move fast.
Could the modeling groups or the various dashboard developers be generating any more information that would be done quickly enough and digestible and fast enough in real time to help with that?
Yes, I think so, especially if you were able to integrate in, actual observed data as well. What that would do is it would quickly get us to the point where we're not developing our own in-house tools, which there's a lot of benefit for. But if we were to have assistance with kind of building out that process, it would definitely speed up the process for us.
Go ahead.
Well, I don't want you to take my job, but the way we do things in emergency is very old school. We do have our in-house model like I showed last time, but even that is sometimes not fast enough for us. So what we do is we have our trusty Excel spreadsheet, and we looked at all the forecasters, and we start with no precipitation event, and then we would make multiple copies, and then my retired boss now would basically, hey, run me a scenario, choose an analog year 21, put in no precipitation, estimate our demand to be 20% less because it's been cold and wet, and run and see what happens. And then we then play on basically what you guys did with the how much should we release, but we optimize it daily. So we forecast out for the rest of the irrigation season, and then I basically tweak it day by day in that scenario. And then once we optimize it, then we save it. And then by the time you're done, you have many versions of Excel that are very confusing.
Yeah, so at DWR, our charge is to produce the seasonal forecast. So I don't think I can answer super detailed about your question, but I mean, obviously, if there's a flight that happens, we're going to look at how that might change the snow state. And, I think the presentation that Mark and Deems gave yesterday on the difference between a basin-wide average, index that, someday I hope we can implement versus our station index. That's typically what we do, snow courses and snow pillow data. But obviously with the graphs that we saw yesterday, they were sometimes very different. And that was very intriguing to me to see how that will work. And so when I say we're in our infancy, I mean, some basins only have 3 years of flight information. And so I think, as Noah alluded to, that we need 20 more years of data. That's kind of where I'm sitting, is that we need the building up this many years of data so that we can start to use that spatial data more as a input to our models than just a point-based data scheme. But yeah, I mean, with all the snow products, we're looking at seeing what happens and why they're diverging where they are, but it doesn't necessarily influence our forecast from week to week.
Would Getty forecasts, so in California this last year, ASO Wharf Hydro moved up to weekly cadence, about halfway through the season, more or less. And I think we've got some ambitions to try and do that in the other domains as well. Do you need even more frequent than that? Is that helpful in the regard of most of the forecasting problems that we're talking about?
For us, we're at the point where we have our tools and our framework and our process where we like to process data. We like to look at it a certain way. We have to get it into our model a certain way so we can run the operations. So for us, the big thing that we want isn't so much the reports, is we want the data. We want those CSV files so that we can upload it into the model and actually truly see those what ifs. I'm a big fan of ensembles, especially if, small plug for the Tahoe tour. When it comes to Lake Tahoe, we have an upper legal limit that we have to maintain as insofar as practical is what the court order says. And insofar as practical is difficult when you can only release, say, 2,000 CFS. And in flood events, we've seen over 100,000 CFS coming in. So when we're operating Tahoe for the insofar as practical, the legal limit, we have to look at the full range of ensembles. And we have to make sure, are we protecting water supply on one side? And on the other side, are we going to be flooding, or going above that legal limit? So it's a risk that we have to manage. 2024 was a, averagely average year, as many of us have called it. 2024, we had to spill water from Tahoe, but we just had to spill a tiny bit of water at Tahoe. In that case, I would want your CSV files every single day, because every single day, sometimes twice a day with the RFC forecast coming out, we were looking at it to make sure that we were still in the safety zone to protect water supply while reducing the chances of hitting that legal limit. So more often.
I think we heard that from Matt yesterday as well, more often. Stephen.
Perhaps to kind of save on a workload, it's not so much that we want the entire season forecast updated multiple times a day. It's more of a, within the CNRC, we look at the most is the 4x5 in the next 10 days. And we really appreciate it when they ramp it up to 3 during storms. And sometimes that's all I'm waiting for in the morning. My spreadsheet's all open. I have all my things there and I'm just refreshing. Hey, they usually update this around 8:30 to 9. Are they here yet? So.
This came up last year then. It's come up most years since we started this, which is, a trade-off of having the reliability of a regularly cadenced forecast versus, at least from an ASO perspective, the company priority to get a forecast out as fast as possible after a survey comes around. Do you guys have a sentiment on that? I mean, the ideal may be the best of both, but is reliability of the cadence, it sounds like that's almost taking some more importance than a really quick turnaround from a survey. Recognizing you'd never be more than a week away from whatever was being generated.
So kudos to ASO. We've always gotten our report within like 2 days.
Snow reports, yeah.
Yeah, and then generally, I assume CNRFC and the other forecaster will ingest it and update all the numbers we're looking at within the next 2 days. And that's good. I mean, if we were in another 2023, I would probably be asking for it during the briefing, right? I mean, that's why we have the weekly briefing at some point twice a week. But on the normal year, generally, within 5 days is excellent.
Yeah, DWR, we're forecasting on a cadence of once a week. We put out our first of month forecast, our big bulletin 120, and then weekly in between. And so that cadence works for us, but we need them on a timely fashion. Like if we're going to consider it for our forecast, we need it on the day that we need it, because one day later is not useful. So would prefer high quality at a slower cadence. Our team is definitely working on a daily operational guidance tool. So eventually get to that point where we are producing forecasts once a day, if not more. I don't know, but I'm not the smart one. That's why we hire smart people. But that is a goal. But for right now, just even biweekly, if it's done well and on time, then that's what we need. So, and you're not the only ones who were requesting. I know Noah's team and CW3E, when their forecasts, we give them the same calendar and say, this is when we're going to do our forecast, this is when we would like it by. Do your best. So.
The way I look at it is there's two distinct different products. You've got the snow products that come out after the flights. That's perfect. For the river forecast, like the regular cadence is helpful, just so we can keep our finger on the pulse. I mean, the big thing that we're trying to do is we're trying to triangulate. You think of GPS, you use multiple points of reference to come up with a single answer. So whether we're looking at the snow dashboard and the different snow models to triangulate to the current snowpack when we don't have flights, or we have runoff volumes, we're trying to triangulate that volume. Now that we're getting more daily forecasts, we actually need tools. We're trying in-house, we're asking the same questions that you kick this off with is, how do we make decisions with, 40, 20 more traces, however many's come in with the ASO Wharf Hydro? Now, RFC has 44 traces. Do we just append the Wharf Hydro traces on top of that? And is that implying some bias towards RFC since there's more traces versus Wharf Hydro? These are the same questions we're actually asking right now, because we're in the place of building out our forecasting system so that we can replace forecast, put it into model, and come up with results and try to make that a useful, educated decision. So really, in my mind, you're talking about two different products. The Wharf Hydro, just the regular cadence is helpful for us.
That's good intel. I want to open it up to the audience just for if any of this discussion has started to trigger any thoughts on anything. So while you're thinking of that, Erik, Skeie, I wonder if you, in your sort of Lord purview of the Colorado stakeholders writ large, do you have any comments or just thoughts on some of these discussion points, particularly this latest one on forecast cadence? And things that can be done to help support the people in Colorado. As Erik, keep in mind, everyone, as Erik talked about this morning, the Colorado program it's a little less centralized, like, the Imperial troopers. It's a little more of the ragtag fleet of, the rebellion out there, a little less organized, let's say. But, and all those stakeholders have a variety of different needs. They operate, you heard Raquel talk about this morning, everything from Blue Mesa, which is massive, to this Paonia Reservoir and even smaller. We heard about the 16 acre foot reservoir in Utah this morning, right? And so, those are really different than the classic B120 forecast problem in California. So thoughts on things like forecast cadence and use of these forecasts for those?
Yeah, so I concur with what Scott was just talking about. Two distinct different products. We got the snow side of things and the Wharf Hydro side of things. We've heard from our stakeholders year over year that a more consistent cadence with the Wharf Hydro would be really beneficial for them, especially because we've got places like the Yampa and Dolores that don't necessarily have their own forecast tools right now. They're trying to develop some at the moment, but since they don't have those of their own at the moment, that more frequent, consistent cadence would be very helpful for them. And then you've got folks like Denver Water and Northern who have their own modeling platforms, but similar stories where it would help them to see those more consistent Wharf Hydro forecasts, see how their forecasts are tracking versus the Wharf Hydro forecasts and what operational decisions they may need to make, so that greater consistency with the wharf hydro would be greatly appreciated in Colorado.
Awesome. Lily and Scott, would that be the same for you guys too, or you guys are there yet with the, because you're pushing it all the way through the operations model at the same time as well.
Yeah, I don't want to totally speak for Central Utah Water Conservancy District, but I think predictability would be helpful for them. Back to the dating theme, I think they're maybe on the second date with the wharf hydro, so they're still figuring out what their triangulation process is. Yeah.
Okay, good feedback. Looks like we got Matt in the back, and then are you Jim? Is that, yeah. What's that? Jim, yes. Yeah, we haven't met. Chan. Oh, sorry. Yeah, I don't think we've met. Thanks. We'll come to you next after Matt.
I was wondering if the panelists might talk about a time when they got catfished by Mother Nature on their decision making and say made an adjustment that was in the wrong direction or a decision that was maybe counterintuitive to their normal.
This is one of the big reason we built our own model, and we build it with water supply as its singular focus. We understand that the CNRFC's mission and purpose is for flood control, and therefore we want to kind of catch the opposite side. And what do we do operationally? We look at both. We always operate with, worst case in mind, both in water supply and flood control. And when flood control events occur, I have a weekly phone call with John, Army Corps. And it's usually, hey John, can I hold on to this? And then John would be like, show me how and why, and then I try to convince him.
We've been catfished in a good way before. One of the good things about the nice things about the Truckee is our water control manual is set up where we are reactive. And we don't actually have to spill in advance, which is really nice. Our control point is in the middle of downtown Reno. And we had a really big forecast, I think it was December 2023, if I remember right, where we were expecting a huge event coming in. We were pulling out our cots in the office and getting ready for long nights, basically, where we would have to shut down the reservoirs to, not add additional water to the system. Storm came in way colder than expected, and I think the snow line dropped. It was like 6,000 feet of drop, enough to put the city of Reno completely in the snow line. And we ended up getting a couple feet of snow in Reno from that storm instead of it all being rain in the beginning. So it's kind of a good story. Before I worked for the Water Master's office, I worked for the Bureau of Reclamation, and I led flood operations on Lahontan Reservoir, which is on the Carson River system. And in 2017, we had a lot of convective storms that were coming over kind of late July-ish. And every time those convective storms came over, even though it wouldn't rain on the snowpack, we saw huge amounts of pulse of melt. And you would see the rivers go up and come back down. We were towards the end of like the peak runoff season, and we were just about out of the woods. And on Lahontan, we don't actually have a water control manual, so there's no flood designation. So you have to try to store as much water as possible, meaning all the way up to the top of the flashboards. We had a big convective storm coming in. RFC was showing this is going to be big, and so we got ready for it. We actually preemptively released a little bit of water, and we missed the top of the flashboards. I think it was by like 6 inches or so, and it was totally in catfished. Luckily, we didn't make the MTV show, so I was glad that I didn't go that far. But yeah, there have been times where, the forecast, we try to be preactive, especially in the Lahontan case, because you're really trying to manage that water supply as best as possible. But it happens. It's unfortunate. But the thing that I would like to say that we've learned from it and grown from it is really that approach of triangulation, of getting all the data sources together in one plot and saying, is there a cluster? Are things grouping together? And is this all telling the same story, so we can kind of better prepare and plan? But great question, Matt. Andy, have you been catfished?
We have never been catfished. No, Matt, you know full well we've been catfished, but you know, like the 2021, right? The many of you know that our group was audited because we were double the forecast on the Feather River Basin. So things like that, that's probably the worst case scenario we've ever had. But in general, you know, we're forecasting 24 basins on a weekly basis, and that's a lot. And there's tons of variability throughout the state, and it's a lot to focus on. So our team, traditionally 4 forecasters, now we've added a whole second group to pull in all this other modeling data. So now we're up to 7 or 8. But so we're working hard. We're trying to catch when we might be pulled one direction or another. Originally, you know, our charge was to cut off our forecast on the forecast date. We didn't look forward. We didn't look at any future precipitation exactly for that reason, because, you know, sometimes there's weather that's promising to dump 10 inches in the next 6 to 10 days. But we never took that into account. We always cut it off. And so the storm came or it didn't. But it wasn't included in that forecast. Now we are looking at least 6 days, looking at perhaps even 10 days. But that can lead to a catfish as well, right? But what we do look at, you know, when we we call it pushing our button on the 6th day of the month, we'll have 5 days of data that we are now including. And so our forecasts in that way are better because they're not out of date anymore. But as far as catfishing, you know, every year there's some basins that don't operate quite like we think we do. Like they're going to be tracking differently than maybe we've seen in the past. So I don't have any specifics other than that feather for right now. But I mean, even the Kings in San Joaquin this year we were high. So it happens. And then we go back and look and see if we can figure out why and adjust and look at other similar years and try again.
Yeah, I just, you know, I have a few comments. You know, my previous career, I spent half my my career as a water manager, and the next half developing software for water management. But this is based on kind of what I heard the last, you know, 2 days. You know, when it comes to all the products that we have, you know, there's deterministics, there's ensemble. You know, we have volumetric forecasts, we have time series forecasts. So there's a lot of products that we use for reservoir operations, and it really depends on a lot of things. Number one, I mean, you're going to look at the forecast, and you're going to, you know, determine just how comfortable you are with those forecasts in terms of how you're going to use those in the context of like either real-time operations or planning. There's 2 different kinds of scenarios there you might want to look at. And ultimately, all these products come down to how you use them in operational context, right? It's all about operations, really, right? So other things that you got to consider, you know, when you're looking at these forecasts is the type of watershed that you have, how the hydrology of the watershed, the reservoirs, operations, whether it's at the reservoir itself or downstream. You know, you got a project operator like the Corps of Engineers, they're going to operate. They have their requirements to operate the project. They want folks downstream, you know, cooperators. They have their own individual needs in terms of like, you know, how you know, what water they're going to deliver to their customers, their contractors, things like that. The other thing too is, you know, with these forecasts, I mean, from what I heard, there's no real one, you know, there's no real, you know, right answer. And it sounds like, you know, everybody's really learning how to use all these additional products that we're getting, right? So, but it also depends on the time of year that you're at, right? Whether it's, you know, it's the fall, you're drawing down your reservoir, it's the spring, how you use the products. They could be used qualitatively, you know, to brief senior management, quantitatively for operations, right? So, you know, there's no one single right answer, really. You know, we're all kind of learning right now. And from what I've heard, different operators use different products different ways. And again, it really depends on, it really can depend on the time of year that you're in. And maybe you're looking at a particular product that gives you more value. Later on in the season, you may be looking at something else that gives you, you know, better insight to what's up there. So it really just depends. So.
Yeah, no, I agree with that. Did you guys want to make a comment before we shift topics to any of that?
I fully agree with what you said. It really comes down to what's going on It really comes down to how's the data, lying together. But one of the things that I really like that you talked about was kind of trust in the models. It's a real thing. It really is about building a relationship with understanding like the data. Lately, we've been getting a lot more hindcasts from RFC, and we are analyzing those hindcasts in many different ways. It's something that we would love to get from the WRF hydro forecast as well. We're now using the hindcasts and the reforecast from the M4 model from NRCS. So we are diving as deep as we possibly can to see how well things track over time. I think we're actually looking at the historical NRCS forecasts back to like 1940 on our system just to see how things are. Trust matters. When you need to make the decision, you got to make it on something that you trust. It was a great point that you made. Thank you.
Yeah, I mean, I've heard from many of their cooperators that, yeah, they operate differently depending on the needs. And so we put out our 50% forecast. That's kind of our best guess at what we think is going to happen based on current situation right now. Not looking at too much future weather, but that's what we have traditionally put our focus on. But hearing from many of you, you're operating at the 90% or the 75%. And so we're trying to be better at that and like scrutinizing the confidence word that we were supposed to use yesterday. What does that give you? Because that's how they have to operate too, is the worst case, or close to worst case scenario. They can't assume that the 50% is gonna come. So yeah, great point, Chan.
That's a good segue. Speaking of confidence, let's talk about weather forecasts.
Actually, Gotchas, I think we have another question on that topic, if that's okay.
We did? Where was that? Eli.
I can be real brief.
Okay.
But I really like the dashboard. I think it's a great way of visualizing. I was just curious, specifically for folks with DWR, if there was just any information on transparency around which data sets and forecasts are included on the dashboard and how those decisions are made.
Well, to not steal Devin's thunder, I think she'll be talking about that tomorrow. She'll be kind of displaying what we are looking at, and we've been starting to kind of introduce that to our cooperators this year at our cooperator visits. Looking at the exact spreadsheet that we look at and all the data that's there, and then again, we still mostly lean on our regression equations, but again, I'll let Devin share that with you tomorrow. But as far as transparency, we've always wanted to be transparent. We don't feel like we want to hide anything. So, our phone lines are open, our emails are open, and we do get a lot of questions, and we interact regularly with all y'all. If the cooperators are seeing something different than we're seeing, we're going to talk about it. And we talk through our numbers. If people ask us for our indices or whatever, we send it to them. So we try and be as transparent as possible. Go ahead.
Thanks. Oh, and maybe to clarify, but I guess I wasn't specifically talking about the what goes into Bulletin 120 as much as which products are the different colored lines on the dashboard.
One more time. Which it's hard to hear with the speakers.
Which forecasts from different groups are going on the dashboard as their own numbers, right? Not just what's being blended into Bulletin 120, but the CW3E LSTM is up there. ASO WRF hydro, both with assimilation and open loop, are on the chart. To just where those data sets are, which ones are being put on the dashboard or not.
Are you asking if there's a decision-making process?
Right. Yeah, I'm asking how do forecasts become eligible to go on the DWR dashboard specifically?
I think Dave wants to answer this.
Yeah, I will give some insight to that. It comes down to this. We're being held accountable for decisions, and we have to know what are on those products and why we're using them. So I think the heart of your question is, why aren't other models on there? Because we don't know the other models. And those are products we're using, we're investing in, we have some track record with. And so we can at least have a chance to defend them. So why aren't we bringing other ones in? Because we have 4 people. And the heart of some of this discussion earlier was bandwidth. if we start bringing lots and lots of other things in, quality goes to shit. Sorry. Quality goes bad, because we've exceeded our bandwidth, right? And we do get questions from a lot of groups. Why aren't you using my model? What time do I have to look at your model to then put it on a public website, which then somebody's going to say, are you using that? Why aren't you using that? And our only answer to it would be, I don't know anything about it. There's a lot of models out there and we respect that. But when you're a state agency, you have to look at it as, why are you putting up that with public funds and why aren't you using it? Or why are you using it? Scrutiny, scrutiny, scrutiny. And I think that's the view you have to look at. We know that your model, there's a bunch of models out there that are really good. It just comes down to, can't look at everything every day, all the time. Yeah, and I think part of the question, back to some of your panel too, is just the frequency. We're overwhelming ourselves, right? And I'm going to have a discussion with Noah too, just on his presentation on how can we leverage some of these things to find these blind spots rather than perfecting an AJ or a monthly. Where are the, some of your analysis might be able to identify blind spots that we're not seeing, so maybe that gives you some feedback too, but yeah.
So I kind of think one of the things you're pointing out, Dave, is you can only date so many models at once, right? Because otherwise you end up just, yeah. But really, I just want to say that. But the trust point was key too. And as somebody who's been a little bit on the other side of it, and I gave the little history lesson back to the late 90s when Tom and I were office mates, but it was a very slow process to develop the relationships that led to our data being utilized. And I think that's true for all the lines that are on that graph, right? Is that it's a slow process and continuity is so important, right? Because you can't develop that trust unless you know there's going to be continuity in the information that you're generating for the end user.
Good. All right. That was a good riff on a lot of that. Thank you. And of course, as Stephen and everybody's been talking about, to Eli's point, there are a lot of other models. A lot of them are in-house models, right? Also aren't on the dashboard. And that's part of the challenge, right? Is just knowing what exists. So, yeah, getting back to weather stuff and confidence in weather models, it's obviously probably the hardest prediction problem we have is knowing what the weather's coming. But we got a little scare, I think, as a community this spring when, the proposed cuts were coming to the U.S. National Weather Service and, either aspects of quality or reliability of some of those products came into question. I would say, I think it's started a series of discussions with a lot of us in this community about, okay, well, if that somehow disappears, what do we all do? What are we thinking about in terms of backups? What new avenues might we want to be exploring anyway with weather data, and how does that sort of filter through to affect our our forecasting confidence and how we end up making decisions? So I know a number of us are looking at things like ECMWF. There's a ton of different weather tech startups doing AI blended forecasts and things like that for weather. We'll see how that all pans out as time goes on. But as a slate of operators, I guess it's a hypothetical at this point because the U.S. Weather Service didn't go away. But what did that experience sort of bring to mind in the discussion of your operations from the sort of prediction problem? And how would we continue to make forecasts and make decisions if we lost one of our key data providers, in this case for weather?
I think I felt like what my boss had to do 20 years ago. It was terrible. we looked at for example, this last year, we had CNRFC had an outage of like a week long and then a few more days. And after all the announcements, I don't know about other basins, but for my basins, it seemed like the soul of the forecast is gone. It's like we reverted back from, someone looking at our basin to a machine putting out the number. And we noticed, just summing up, recent past, like seasonal, cumulative, that things were not lining up. And I don't even want to point it out because they are worried about if they're going to have a job. So what do? I made a note to my management and we applied, the spot offset that I found. Is that offset correct for the whole season? Absolutely not. I was basically floating a little bit blind, and thankfully they seem to kind of somewhat, waddled up. But yeah, so I don't want to think of a worst case future, but that was a good scare exercise, I think, that we all needed.
And in our office, we talk about forecasts. I shouldn't say this, but ad nauseum. We have all of us, we all sit in our own offices and we go together and we look at forecasts in so much detail. Every single product you can think of, we go over, we discuss, we kick it around, we decide one thing, we go back and we do it ad nauseum because not only are we all weather nerds, but it really does matter for our operations and for understanding what's going to happen in the future. I have to say that the thing I'm most grateful for is that we have amazing relationships with our forecasters. We make sure that, we know them, we talk to them, and we try to do our best to stay in the loop with them. And we also inform them what we're doing as well, just so we can have that relationship. And having that relationship has been able to quell some fears. And I'm just grateful that that talk has gone away, at least for now. So.
We are, yeah, that was a big scare, and we're still playing the game as what if, because it's not over. So at DWR, we have a budget change proposal to bring a lot of that river forecasting ability that the RFC has done over the years in-house, so that we can continue to do what we're supposed to be doing. So Dave is much more in the details. I don't know if you want to take a mic again, but we do have a budget change proposal for that scenario. I don't know if it's all weather, but it's definitely river forecasting and day-to-day operations that are so critical to all of your decision making. So we're still playing the game that it's going to happen. But thankfully, these are people. We work down the hall from these RFC folks, and to just watch them go through this experience has been awful. They're tearing their hair out. Do I retire? Do I go? Do I stay? And out of the goodness of their heart, many of them decided to stay, and looking like it's okay, but we just don't know. So big questions.
I just want to add, if you guys build that out, remember there's a couple points in Nevada that matter too.
Is anybody from
Please?
Oh, go ahead. Yeah. Is anybody from CW3 still here? Nobody's here from CW3 today? No? Oh, okay. I'm going to see about West Wharf and some impacts on that. I think we're getting close to the end here. Molly, correct me if I'm wrong. We're within a few minutes. So let's give a big round of applause for our three, I don't know if eligible contestants, and very brave to come up and talk about, those things. Appreciate it.
Now, are you going to choose a winner?
What's that?
Are you going to choose a winner?
I mean, we could throw it out to the audience to choose a winner, but I don't know. Yeah.
There'll be anonymous voting.
We're not gonna do
Thank you, Gotchas. Awesome. Thanks for a great second day. We'll see you all tomorrow.